And good morning, all you beautiful people. Oh, sorry, I got that wrong. Not good morning. Good moaning. Good moaning. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Hang on. What was that? What? Come on. I'm trying to quit out of something. Focus is wrong. Focus. What? macOS's window management has just gone berserk. I don't know what it's doing. I'm going to ignore that. And instead, I am going to talk to all of you lovely people. All right. So I still don't know if Mitch is calling me a fungus or a werewolf. Either way. I take it as an upgrade from my current condition. Whatever I am now, becoming a fungal werewolf would be better. Look like a rocky start? Yes. Mooning? No. Stephen W., it is not good mooning. Mooning is never good. Never. Ever. Okay.
Imi said to say hi.
Imi! Hello, Imi. Hang on. Okay, I'm just going to get to saying hello to people. Who do we have here? We have Mark Laguda is here, and Crispian, of course, who just spoke up on behalf of Imi. Gerald42, Scott, John Whips, Stephen W. Mitch is here. Well, not here in person, sadly, but here in chat. David Howes, Sharky, Any Mules, Tech Nebulous, Yusuf, Stephen George, Andrew Brown. That's all I've got in the little TTS list so far, at least. Whoop. Yeah. All right, so morning in Melbourne. It's already midnight in UK, said Yusuf. Midnight. Yeah, so it would be. So we are currently at GMT plus 11 because we're on daylight savings time here in Melbourne. So it'd be, wouldn't it be 11 p.m. on Saturday in London, in the city of my birth? Should be. Back in time. Back. Bracket meeting. Oh, okay, sorry, I'm just catching little snippets of the chat that are going on. Crispian was talking about the drag racing in Ballarat and yeah, okay. Yusuf said 12:03 a.m. Oh, that's interesting. John Whip said midnight. Yes, Crispian says she's not here. I know she's not here. Imi is on a train, I think you were saying earlier, but you said that she said hello, so I was just saying hello back. Even if she can't hear me right now. What is going on? Okay, now, I do have a plan for today. And I did something last night. I did a few things last night, but the thing in particular is I did, hang on, how do I do this? I was messing around with my streaming setup because it has been annoying me so much that I can't show the oscilloscope screen on the stream. So I did a really a dodgy thing, and I got a webcam and I pointed it at the screen of the oscilloscope. Aha, other people, Tabraze is here, good morning, and Clifford Bradbury is here. Okay, so what I did was, let me see if I can figure this out. I'm going to disappear and you're going to get the overhead camera. But I've got this. So this is the screen of my oscilloscope being shown by the crappiest webcam that ever did happen. Stephen W asked, do you have an alternate level shifter for the I2C? Yes, potentially. I have an alternate level shifter. So what I wanted to do today is run the I2C bus, stick the oscilloscope on it, and see what the signal is doing. Because my theory is that the problem lies in the level shifters. So, David said, I'm in the carpentry workshop for the day, so no screen, just audio. Okay, in that case, I'm going to have to describe the oscilloscope screen to you. Imagine a field of darkness with a grid laying upon the darkness. Upon that grid is a yellow trace, which is jittery jiggering left, up and down. There, I hope you got it now. Sorry, I'm just opening. I'm opening Fusion because I'm going to pull up the schematic. All right, so the plan for today.
Focus, you freak.
Focus, you freak. Yes. Yeah. Okay, so Scott would obviously get the Will It Chooch reference. You know where that's from. Yeah, it is the crappiest webcam ever, but it was what I could pull out at the time. And the funny thing is that it seems to be a bit of a a bit of an exposure issue. If I switch back to here, I'm going to switch back to that. So if I stick my hand in here, it's like it suddenly is able to focus a bit better. Can it focus there? Yeah. See, it's actually almost focusing on my hand, and you can see that the text through there is a bit clearer. I take my hand away and it gets worse. It loses focus. I think it's because of the reflection off this screen surface, which is stopping it from, it's making it have trouble focusing. And by putting something not as reflective in front of it, it focuses better. Try putting a pinhole setup on it. Yeah. Oh, Jaxtech said your oscilloscope doesn't have an output capture. It does, but yeah, there are caveats. Yeah, Crispian said I reduce its iris. Yes, that's right. Turn off auto exposure and white balance, says Jaxtech. I would if I could. Okay. This is squirrel chasing territory. I could be chasing, so going back to here. So I could be chasing how to improve this situation. Okay, compose yourself. Come up with a plan. I will summarize the plan, then I will slightly detour and chase these squirrels in relation to some of the comments people are saying about capturing the oscilloscope, and then I will come back to the topic. If I say the topic, it means that I'm committed to returning to it. The topic is if I switch back to here, no, that's not what I wanted. I wanted that, and Testomatic, and where are we? Testomatic 2.1, that will do. That will do, donkey. That will do. And so the plan is to find out why part of the I2C bus is not working on the current Testomatic design. If we look at the... get off there. If we look at this, we've got IO2 and IO3
Scott Miller said, when was the last time we saw the actual squirrels on screen?
Ooh, the actual squirrels. I can see them. You don't trust me? You don't trust me that they are safe and sound and sitting on their pedestals. So we've got IO2 and IO3 as SDA and SCL. So this is the I2C bus, which is coming in from the Raspberry Pi at 3.3 volts. From there, it directly connects to some devices. For example, it directly connects to, let's find something. It directly connects to the INA260 current sensors. Here you go, IO2, IO3, SDA, SCL. And those are working. So if we scan the bus, in fact what I should do, while I'm talking, I'm going to turn on the power supply so I can start the tester so that we can actually get a signal out of this. Not much point measuring a signal when there's nothing to measure. And where is that power cable? Is this it? No, no. Where is the power cable? I need a power cable. Oh, I think I know where it is. It's over here somewhere because I was going to take it with me to a customer job. which then got cancelled at the last minute, which was the way of my week. This week just gone. So, what am I doing? I am, where are we? Overhead. Overhead. So I need to get power into this. Yeah, so, come on, come on. What do I want? Let's give it 12 volts, 8 amps. That should be enough. Go. And now we got the power LEDs have come on. We should get the screen in a second. I saw it flicker there. So there we go. The Pi is booting. And if we grab one of these handy dandy breakouts, here's some I prepared earlier, and jam that in. This now exposes I2C just here, and there's a ground connection, so we can stick the oscilloscope on there and see the 3.3 volt version of the I2C rail. Now, coming back over here, as I was saying, we have I2C working on the devices that are on the 3.3 volt I2C rail. So that is all the things that are directly connected to that bus. However, here is the kicker. Those signals also go through to these level shifters, which are using these MOSFET based level shifters. And we have 5 volt versions of those signals. There is SCL 5 volts, SDA 5 volts. And the devices that are on the 5 volt version of the bus are not working. That includes these. The ADS1115 ADCs, the DAC is not working, the MCPs are working because they are still on the 3.3 volt. So my theory is that these level shifters are balked. And what I thought this would be a good opportunity to do is to throw the actual I2C signals on the scope, up on the screen, and we can see what they're doing. Can you hear all that noise in the background? It's a fine Sunday in Bayswater, and there is a car meet nearby. It's been a constant stream of Japanese resto mods going past this morning. Yeah, so I don't know, it could be interesting because I'm sure there are people who have used I2C but have not necessarily seen the signals. Like you know the concept, but you don't know what the actual signal looks like, the clock signal with its little regular patterns and the data and all of that sort of thing. So yeah, I thought it would be cool to bring the scope up and have a look at what's going on and why the signal on this side of the level shifter is not necessarily getting through to this side of the level shifter. So we're going to do ourselves a little diagnostic. How about that? Proof of life. Crispian wants proof of life. Yeah, I'll give you proof of life. Okay. Proof of life. Hang on. Proof of life. Oh, Crispian says, please install an outside webcam so we can see the passing parade. It'll double as additional security too. Oh, I intend to. Scott said 2N7002 is a through-hole part. Is that what you actually used? The 2N... I didn't even know it was available in a through-hole part. Hello humans, Henrik is here. Hello Henrik. And good morning or good, no, it'd be good evening or good midnight Estonia. What is it now? So it's now end of October, which means in Estonia it would be getting to the point of being friggin' cold. Heading into the coldy coldness Yeah, it's 2 a.m. here, says Henrik. Yeah. What was I doing? That's right, that's right. I was going to go for... Okay. Since their fans demand it, here is proof of life. Steve and Stev. Yeah, Steve and Stev. There you go. So now you don't get to see them for another couple of months. Yeah. So that is what I was wanting to do. Let's investigate some I2C signals. Put some probes on them signals. I will, Stephen. I will. I will.
Scott Miller said, Steve Steph.
Yes. Hang on. A couple more people have arrived. Mitchell, good morning. Jax Tech, David Crisp, James Harris, and I already said hello to Henrik. All appeared in the list. Yeah, we'll put some probes on them signals. So, okay, here is some homework for you. Hang on, some homework for me is, I'm going to take another swig of my coffee. Just a second. That's it. Now I'm fueled for the next 1 hour and 43 minutes. Tassie Bob, Casio. Haha. You both made it. Excellent. All right, now I need to solve the problem of capturing a scope. This is one of those things that has eluded me for so long. Now, some options. Option the first. What I'm doing essentially now, which is pointing a webcam at the screen.
Said, TTS back. Remember kids, disconnect power cable when you work on circuits.
Disconnect power. No. Just keep at a distance and engage your safety squints. Then you'll be fine. Okay, so Stephen W said HDMI output. Yeah, I'll get to that. So option the first is doing what I'm doing now. Point a webcam at the screen, but do it properly. So get an actual proper webcam that is modern. This one is probably 20 years old, and I don't think I can control the autofocus or the white balance or the exposure or anything on it. It is a truly rubbish webcam. And I get a proper little camera pointed at the screen, fixed focus, etc. Make it all schmick. Capture it on USB, which is what I'm doing right now. So what you're actually looking at right now is QuickTime Player capturing from a webcam. That's essentially what it's doing. So it's USB into my computer, and then I'm doing screen capture off the computer. Option the second, HDMI out. Not as easy to find as you would think, and there is a catch. I have gone looking for oscilloscopes with HDMI outputs. There are a few. They tend to be, like the higher end ones generally have it, the expensive scopes. There are some in the reasonable price range now, like $2,000 scopes, $2,500 scopes with HDMI out. But here is the kicker. It is almost exclusively at 1280 by 600 resolution. If you, Stephen W said Rigol 5000 series. Yes, that's what I was looking at. Their output resolution is 1280 by 600, which is an unusual widescreen letterbox format. The reason it is 1280 by 600 is that most modern oscilloscopes run Android. If you buy a modern touchscreen oscilloscope, that 7-inch touchscreen, or whatever it is an Android tablet embedded. That's essentially what the front end of the oscilloscope is. And so it's like you've got a big tablet or a big mobile phone or a small tablet embedded in the oscilloscope. And they are generally designed to have that narrow, tall format like for a phone or a tablet. That's just the way phones are designed. The aspect ratio of a phone is very different to a normal monitor. So what they do is they have the phone resolution, the 1280 by 600, turned sideways. And that's what you're looking at. Oh, jackset crackling noise? Maybe. All right, I'll see if I can do something about the microphone. Hang on a second. I don't know if that'll be any better. I just relocated the microphone. Hopefully it won't be as crackly. Maybe it's not the, maybe it's the shirt or something. I don't know. Maybe I'll have to take my shirt off and just stick the... No, let's not do that. Much better. Okay, thanks. And also, I will try not to shuffle around. I tend to not sit perfectly still. I move, and yeah, when I'm doing stuff, I sort of jiggle a little bit. So I will try to overcome that habit. Scott. Maybe we'll get Scott's comment in a second. Oh, and Johnny, thank you for the membership. I haven't heard that come through on TTS. Yeah, maybe it'll catch up. It'll catch up. But Johnny, thank you for the membership that was picked up by Casio. Okay, I'll turn the gain down on the ATEM a little bit as well. So hopefully that will help with the microphone problem. All right, so that is the problem. Now that is actually my lead option. However, 1280 by 600 is not a resolution that is supported by the ATEM for video capture. And I need to be able to... Oh, Mitchell says refresh. Okay. Refreshing the TTS. Loading, loading. Here we go. Let's see. Come on. Refreshing, refreshing. I am just waiting for it to load. Yeah, so I'm not sure what's going on with it, so I'm just going to let it sit there for a minute and see if it loads. I actually contacted Blackmagic and asked them if I could ingest 1280 by 600 resolution HDMI into an ATEM, and they said no. At least that's the official word. Officially, it is not supported. So I can't just go out and buy a Rigol 5000 series scope, plug in an HDMI cable and capture it. I mean, that would be the really nice solution. That would be really, really nice. Scott says, Mitchell R, master of balking text-to-speech. Yes, but it was Mitchell who built it in the first place. So, yeah. You can't really say he's the master of balking it because he was a master of creating it. Yeah, VGA capture card, says Jack's Tech, but that means you need a scope with VGA out. And what scopes have VGA out? I haven't seen one. I don't know if I've ever seen one. So, what else? Okay, so, if buying a Rigol 5000 series scope solved this problem, I would do that. But I am not sure that it would. So the unofficial word from Blackmagic is that with an EDID faker dongle, I can probably ingest 1280 by 600 into an ATEM. So that might solve the problem, but I don't know. And I don't want to buy a multi-$1,000 scope and then discover that it doesn't solve my problem. So option the third, which I've seen a couple of people come say in the chat, is a software-based scope, like a USB scope, which means I could run the software directly on my computer and then just screen capture. Now that may actually be the best way to do this. And Simon said, oh, Simon, I don't think I've said hello to you yet. Good morning, Simon. Simon said, buy an Analog Discovery 3. They are truly awesome for diagnosing all types of serial signals. I2C, SPI, CAN, UART, etc. So Analog Discovery 3. And then I would run the... run the software on my local computer and screen capture it the way you can see I'm screen capturing here. Andrew says, for capturing videotapes, I use a presentation switcher that takes a whole heap of analog and digital video inputs and outputs to HDMI at a fixed resolution, scaling, letterboxing, etc. Yes. Oh, and Stephen W says, use HDMI capture into the PC with OBS. Yeah, that's a good option as well. I have a couple of USB-based HDMI capture devices, a few different types. Oh, Henrik said, also use the program that Adrian Digital Basement is using. It's so cool. GPBit. Yeah. Jackstech suggested GPIB. Okay, so that is the alternative, is to pull data off the scope over the network. That is another way to do that. And yes, I can do that, but it is really slow. It's not live like this. Here you can see the dynamic signal. You can see the numbers changing. You can see the scope. You can see the trace jumping around. If I use Skippy or GPIB to pull data off the scope, it takes several seconds to do a screen capture. So it's like one frame every few seconds. I actually did that. In fact, I wonder if I've still got it here somewhere. I might have deleted it. I pulled a, is it this one? Is it this one? No, not that one. Oh, I can probably get it back. Hang on. Let's see if I can get onto... Whew. If you give me a moment, I will show you the result of this, because the result is actually perfect. It's just too slow. I've just got to log into an Ubuntu box where I was doing these experiments. And where was it? In Rigol. Oh, here we go. So I was using a random Ubuntu machine on the network to do this, because the screen... in fact, what I can do is... Scope snap. Okay. I'm going to bring it up on screen and show you what happens. Oop. Oh, I can't do it to that while this is in full screen mode. Okay, we'll get that out of the way. We'll bring this up. So I'm on a different box right now, and I've got this, whoops. I've got this little script called scope snap, which is going to make a network connection and store it into output.png. In fact, let's make it output2.png, and in fact let's see how long it takes. So I'm just going to run that, and it is now pulling data off that oscilloscope. Oh, and to answer the question, someone else asked me what scope do I have. It's a Rigol DS2072. Okay, so reading data. So it's still going. This is how long it's taking to pull a screenshot off the scope. And then what I will do is... Oh yeah, it finished. Okay, so it took 27 seconds to do that. Now, I know you can do it faster. I know you can actually pull a screenshot off probably a couple of times a second. I'm going to do SCP, what am I doing? KO at ko1.local. Rigol, what was it? Output 2.png, and I want to bring it here. And now, where did it go? Where did it go? Somewhere on my desktop should be that image. Here it is. Okay. So this is the result, which is perfect. Like that, if I could capture this in real time, that would be the dream. I want the full Rigol interface at proper resolution and showing the trace and everything, all the data. But I want to, this screenshot, as you could see, took 27 seconds to pull off the scope. So I want to be able to do it much faster than that. If I could do it a few times a second, that would be good. But what I really want is like full frame rate. I want to be capturing it like this, but with the quality that you saw on that screenshot. So that's the goal. Now, analog discovery. Why haven't I got TTS back yet? I'm just trying to load. I'm just reloading it again. We'll see what happens. Okay, I'm going to go back to the start of it, log into the portal, pick the latest. Oh, it says past streams. It thinks it's a past stream. That's odd. Yeah. So it thinks that today's stream has ended. QSay, is that like quick say? Henrik said, can you look at Discord DM? There are 2 create links. Okay, I am going to anonymize my screen so that I can pull up Discord without revealing too much. All right, what is it? Oh, here we go. Rigol, HDMI output and touchscreen. Ooh, look at this forum post. Visit site. Yes, I do want to visit that. So this is a link that, hang on, I'm going to take that off the screen, then bring something else up before I, yes, visit. Before I let you see it, here we go. I've muted it so that I don't get a copyright strike from Dave. I don't think he would copyright strike me for talking about his stuff, but yeah, the YouTube algorithm may do it. This is Rigol DHO 800 HDMI output and touchscreen. Is, ooh, yeah, that is pretty friggin' good. All right. Thank you very much for pointing me to that one, Henrik. My guess, though, is, oh, look at that. Look at that. That is so nice. Okay, I'm going to check that out later, but I'm guessing that this is not, hang on, USD 280. What? What? I thought this would be like a $5,000 oscilloscope. Let's see what Emona have got it listed for. That is kind of crazy. Like, is there a buy now button? What the hell? 250 megahertz 4-channel version is only 1351 plus GST. Oh, with the arbitrary function generator? Oh, that would mean I can get rid of the function generator that's currently on my bench and move the multimeter up to where the function gen is. Ooh. I am so tempted. Okay, before I do, I'm going to spend a little bit more time looking at the yeah, at Dave's take on what it is. But yeah, Scott says, boink, John's bank account just felt it. Yeah, that might be a that might be the answer to the problem. Wow. And he said the roll can change to the screen resolution, whatever it is. Wow. Yeah. Whew. Okay. John Whip said, how soon can they deliver? Perhaps this could become an unboxing stream. Oh, Mitchell says TTS should be good now. All right, I'm going to reload on that. It looks like TTS might be back. And hopefully it is. Hang on, I had my audio muted because I didn't want to be copyright striked on Dave's video. So also good morning to RJ, Mr. Fixit, Tassie Bob, I think I said hello to earlier, Andrew Gordon, Freddie, Jay, thank you for coming along. All right, say Q, Q say test, say Q. Okay. Yeah, now the Analog Discovery 2, was that the one that, or Analog
Test.
Discovery 3? Yes. Is there an Analog Discovery 3? Yes, there is. Show me an Analog Discovery 3, $649 at App Vision. All right, so this is, yeah, we are still chasing this squirrel, but it is all relevant and it is all useful and interesting, and I have a possible solution to my problem now. So 100 megasample a second USB oscilloscope, logic analyzer and variable power supply. Yeah, waveforms, yeah. Now, where's the software? Can I run the software on my Mac, or will I need something different? Where do I get the software? Description, product details. Okay, product details are description. Analog Discovery 3 Mac. Analog Discovery 3 Mac software. Let's see. Waveform software. Ah, okay, so waveforms is the software.
Scott Miller said, education discount. You educate us.
I educate myself, is mostly what happens here. I get on, I display my lack of knowledge about something, and then you put me on the right track. So I learn, it's educational. Download and try now, yes. Let's do this thing. Loading. Does it have a Mac version? Yeah, except those.
Said.
Login. Okay, to my products. Okay, do I have a Digilant login? I may well do. I'm just going to. Whoops.
Scott Miller said, okay then, we educate you.
Yes, you educate me. You sure do. Pass. Digilant. I'm just checking whether I have a Digilant password. It appears I do not, which means I would have to sign up. No account, create one. Yeah, sure, why not? Loading. All right, how about I do this down here, where you can't look over my shoulder quite so easily. And now, generate a random password, and let's go, baby.
Then student discount, even more.
Okay, signing up. All right, so it's apparently sent me an onboarding email.
Henrik Ostrov said, comment allez-vous aujourd'hui?
What? Henrik, what are you trying to tell me? All right, confirm your Digilant account, confirm email, yes, confirmed, log in. I mean, I get why they put a gate in front of this, but this is just to download software that presumably I can't use unless I buy one of their products. So Waveforms 3 Mac. Download. Alright. Is it downloading? Yes, it is downloading. I'm going to try running it on here. And we'll see what it looks like. But down on the other monitor, I am staring at this Rigol DHO924S. Yeah, I think this is going to be a purchase. I think it is. This could be my new scope for the next 10 years. Could have been. Something else is just going past. Alright, where is this download thing? That. Oh, alright. So this is the Digilant installer. So I'll drag this to the applications folder. Alright. Let's done that. Now it's saying drag the icon below to your frameworks folder to install for custom applications. I don't think I need to do that because I'm not going to be doing custom applications, I think. Let's find out. Oh, something else just popped up. This popped up on my screen because of the change of focus, which is something else that I could tell you about, which is Testomatic related and kind of cool. But I will avoid chasing that particular squirrel for this next. I'm going to try to resist it for the next hour and a bit, unless I have time at the end of the stream, and then I will bring it up. So, what was I doing? What was I doing? That's right, I was looking for waveforms. Are you sure you want to open it? Yes, open. So yes, Analog Discovery 3 could still be a worthwhile thing. Allow to find devices on local networks. I will, because I think it needs that. Alright, so new workspace. No device detected. That's because I don't have an Analog Discovery device manager. Oh, okay, so these are all the different things that it can use, including a sound card. Discovery 3 demo, whatever. I don't know what select and dual means. No idea. Alright, so this is the Analog Discovery Wave software. Scope. So we can go into scope mode. Okay, so we've got all these different workspaces. WaveGen. Yep. Voltmeter. Yeah. Cool. Logic analyzer. Spectrum analyzer. This is pretty cool. Ooh. Network graphing. Like for, like for fast Fourier transforms and things. Impedance analysis. What else? Tracer. I don't know what tracer is. Protocol. Oh, it's got decoders. CAN bus, like a CAN decoder. Oh yeah. Oh yeah. So Analog Discovery may well be AVR. What is AVR? Reset clock, MOSI, MISO, fuse lock calibration. Is this specifically for interacting with an AVR microcontroller? Oh, it's got SWD as well. And JTAG. Yeah, and UART. So that's pretty cool. So protocol decoder, script. Okay. Whatever. Don't know what that does. Supplies. So we can do programmable power supply control. Logger. Lots
Henrik
of stuff.
Ostrov said, also send a message to Wriggle MB. They can just send you one for cheaper or SMT.
No, I don't think they will. I am not enough of a channel to have people send me stuff for free. Yeah, I've tried that before, and I don't even get replies. I haven't tried with Rigol specifically, but yeah. Yeah, okay. Analog Discovery Pro. What's the... All right, now, if I was going down... Ooh, there are a lot of Analog Discovery models. There was the Discovery 3 is the one I was just looking at, which was $649. What is with the logic analyzer, variable power supply, pattern? Oh, okay, so these ones have got things like programmable power supplies built in. So ADP 2230, 3250. Presumably these ones are fancier and more expensive. And there are a number of projects as well. Like there's a project on I think it's on Kickstarter at the moment, which looks like a very interesting, fully open source oscilloscope project. So it's building a front end for a scope, a similar sort of thing. Oh, USB interface, nice front end, good analog input stage. It looks really decent, but it's still a fair ways off, and I think it's going to be not particularly cheap when it is ready. And I can't remember what it's called. So yeah, Analog Discovery 3 could well be a solution to this as well. So thank you very much for the suggestions. All right, I haven't even seen chat. It got obscured by some windows a while ago, and I've just been sitting here talking to myself and ignoring all of you. The window focus has gone a bit strange. All right, got to close that, get it out of the way.
Henrik Ostrov said, ask from friend Dave, then maybe he can give you some good ideas.
Yeah, maybe. Simon said, click protocol on the left. Yeah. A message to AVR. Is that Harvey's cousin? Actually, yeah, AVR and AVE are related in an obscure way. So, yeah, John Whip says, meanwhile, those I2C level shifters are not going to fix themselves. Right. Oh no, Mitchell says, damn it, Magic Smoke. Heck, need a new coffee machine. What, did you just let the Magic Smoke out of your coffee machine? That is truly tragic, Mitchell. I think we need to start a coffee machine fund for Mitchell, because you can't push electrons around without caffeine. Oh, and Stephen says Salier logic analyzers have great software for protocol decoding. Yeah, hang on. I actually have, where is it? Logic. Oh, I don't have it installed on this computer. I've got it on my laptop. The Salier, I don't know how to pronounce it. I always say Salier. So I have the logic software on my laptop, and I actually have a Salier logic analyzer around, but what I want is the, yeah, which is great for protocol decoding, but what I want is the waveform. I want that. So now let's see if we can figure out what's going on with this puppy. So now I'm going to, how am I going to do this? All right, I need to get some signals out of this. I am contemplating soldering headers onto the onto that breakout. And when I say that breakout, I mean this thing. Oh, this thing here, because it's just got these pads on it. I think I will. So I need, what have I got here? I need a ground as a reference. So I need a 2x6 and a 2x5. What do I have in my little headers box? My little box of miscellaneous headers. So I've got, there is a 2x5, and I need a 2x6. Do I have one, or do I have to actually go to the real thing. I think I've got to go to the real thing. Go to the real thing, which is over here somewhere. The 0.1 inch headers box, right here. 0.1, 1 by, I want not 1 by 6. Oh, actually a couple of 1 by 6s would do the job, but what I ideally want is a 2 by 6, 2 by 5s in semi-bulk. 2 by, I think I'm going to have to settle for a pair of, 2 by 4s. I'm going to have to settle for a pair of, hang on. No, actually I've got 2 by 3s, but they would not butt end to end. They don't quite fit properly when doing it like that. So I'm going to have to go for a couple of 2 by 3s. And yeah, so just swallow that. Of course, everybody has their priorities right. And right now, everybody is freaking out about Mitchell's lack of a coffee machine and how to deal with that tragic situation. So, Mitchell says, I have old school stove ones, manual ones, filter ones, but only one espresso. I like my quad shots. All keeps me insane. Yeah, quad shots, that would keep you insane. Okay, now, this is going to be annoyingly loud, but I am going to do this for the sake of my lungs. So, if you have a voice assistant, you may want to mute it now, or it's going to complain that it doesn't know what you're talking about. Alexa, turn on fume extractor 1.
Okay.
And here we go. No, not that. That. And let's do this one. And some of that. And what else do I need? Some blue tack. And let's chuck 5 volt. Maybe I should stick. So that's 5 volt, 3 volt, 3. That's all USB. Yeah, I could just put headers in some more things while I'm here. But no, I'm lazy. I will just put the headers in the things that I care about for now. So, oh, I'm nowhere near the fume extractor. Get that over here. Come over here. There, oh, you can just see the edge of it there. Did I get this straight? It's approximately straight. Straight enough for government work. So yes, I am right. That DH whatever it was it DH08 something? That looks like a very, very interesting oscilloscope. So what I'm going to do is do my usual sort of deep dive, semi-obsessive thing.
Good enough for Australia Live.
Good enough for Australia. Good enough for Australia. So I'm going to do my usual thing where I become suddenly obsessed with them for maybe an hour or two and read every review I can find and watch everything I can find just to convince myself that I'm doing the right thing, and then order one, I think. We shall see. Okay, I need something to keep these aligned. Looking through my little cache box of bits. Come on, where is a two-way pin header strip? There's got to be one.
John, if you get back to the computer with a product named Virtual Bench Oscilloscope.
Oh, Virtual Bench Oscilloscope. I've heard of I think I've heard of Virtual Bench, or maybe I'm thinking of something totally different. Oh, there's one. Virtual Bench. Yeah, okay. Virtual Bench Oscilloscope. I will get back to my computer soon, and we shall see that. Yeah, my camera setup is not really very good right now, is it? Oh, I know why. It's because I was wondering why that camera was pointing in such a weird direction. It's because, oh, and it's not even pointing at the right angle. I had pulled, this camera is sitting on a, oh yeah, that is the webcam pointing at the oscilloscope. So yeah, that's not ideal. Yeah, I moved all of that around because I was getting to the back of my Rigol to make sure the Ethernet connection was connected when I was messing around with that screen capture script the other day. And I ended up moving the camera and then not checking its position afterwards. I just sort of shoved it back approximately where it had been, give or take. So, back to the job at hand. I'm going to need some jumper wires to extract these signals. And okay, while I'm doing this, I will tell you what I was working on yesterday, and then maybe if there is time I will show you the results at the end of the stream. This is test-o-matic related. Part of testing boards, one of the fundamental things is you need to be able to identify them. Well, in some ways, that is if you want to be able to look up test results and things later. I mean, with testing a lot of the time, you don't actually care. You can just have a big batch of boards and you can test them, and then some pass, some fail, and the ones that fail you chuck into a fail box. But in my case, what I'm wanting to do is serial number every board. And so what I do is I print barcodes that go on them, and then test-o-matic can scan the barcode and store the test results against the ID for that particular board. So yesterday I experimented with different formats of the barcode stickers using my fancy Brother label printer, which I'm in love with. And I switched from 9mm to 12mm tape and went for, I was doing a QR code and a, sorry, I've got to grab some stuff out while I'm talking and I'm having trouble thinking about two things at the same time, because multitasking is a lie. And yes, I've lost my train of thought now. Multitasking is a lie. So what have we got? Ground. We've got a ground signal there. Yeah, what I was doing was putting a 1D barcode and a 2D barcode onto each board. And the 2D barcode had a URL for the, so I2C, where is it? There. Had a URL to go to a portal to look up information about the board, and the 1D barcode just had the serial number alone, nothing else, which could be easily scanned using a barcode scanner connected to test-o-matic so that it could know which board it was testing. Anyway, I have changed the format of that, and I'll show you all of the results of that later. And I made a light box yesterday, so I can, as boards are about to go into their packaging, they are photographed on the test bench from top down, like in controlled lighting conditions in a very direct way. The photos are synced through Dropbox to a virtual machine running on Linode, and I wrote a script that, oh, Mitchell says, TTS will be back in about 10 minutes. Was that an old message? I don't know. Yeah, so I wrote a script that then processes the image and it finds the QR code. And if the QR code is in the correct format with the prefix for the portal, it strips that off and it extracts the serial number, and then it renames the image with pre-pending the serial number of the device in the photo and timestamping in the file name. So then I end up with a whole bunch of photos. So for each device, I have a photo of the board right before it went into its final packaging, with the serial number of the board pre-pended.
Is TTS broken again?
Ah, it seems to be back. TTS was broken, but now it's back. So what am I doing here? What am I doing? That's right. Okay, back to the task at hand. And just because that's annoyingly loud, Alexa, turn off fume extractor 1. Ooh. Let's try that one again. Alexa, turn off fume extractor 1. I wonder
Don't worry,
if...
it'll balk again.
Yeah, it'll balk again. Alexa, stop. Now, what did I do? Let's see if I can... I'm going to my phone to see if I can turn off the fume extractor now. Yes, okay, so local control is working, but the link through the API for, whoops, where am I? She who shall not be named is not working. All right, let's grab, I'll grab the second channel as well. Now, one of the other nice things about going to that scope would be I'd get 4 channels instead of 2. I currently only have a 2-channel oscilloscope because I've got this DS2072. What am I doing? I'm going to put clock on channel 1. I'll put the data line on channel 2.
Alexa, turn on fume extractor.
Is it going to do it?
Fume extractor 1 isn't responding. Please check its network connection.
Henry Ostrov said, Alexa.
That would have worked if the
I'm not quite sure how to help you with that.
Alexa, stop. All right, I have disabled Alexa. So it seems there's something wrong with the API. All right, so we've got what have we got here? All right, so we've got, this is on the 3.3 volt side of the I2C bus. We've got our ground connection here. We've got clock on channel 1. We've got data on channel 2. Oops. And now let's have a look. I've got to do a bit of a switcheroony here, so I've got to get that up on the screen. I've got to switch to, what am I switching to? That. Look at that! It responded. It actually did respond to that command to turn it on earlier. It just ended up queued up and delayed. All right. Now,
Focus you F-R-A-K.
Yeah, focus. Alexa, turn off fume extractor 1.
Okay.
There we go. Okay, so now I have muted. Now I have muted Alexa so that you can't do that. Don't do that to me again. Okay, we have, what have we got? We've got, what, 1 volt range. No, let's go out to 2 volt range. I'm going to turn on channel 2, which is also on 2 volt range. We'll normalize both of those. Drop that to there. What have we got on? So we've got 3 volts on clock. What's going on here? Do we have any signal happening? I'm just zooming in and out to zoom out, zoom out. I don't know what time scale I should be on. I'm just going to, where is it? I'll set the trigger about there, and then we should probably do some I2C stuff and see what happens. Okay, so, all right, what I'm going to do is I am going to bring, oh, I can't do that. Oh, this is a limitation. Okay, if I unfull screen this, you'll still be able to see it, and then what I can do, in fact, what I will do is bring that like that, then I can bring this up here and embiggenify the text. And what I'm going to do is just start some I2C transactions happening on the bus. So, what was it? Tester 3 is the magic identity. What have we got here? Where did I get voltage? Was it get voltage.py from INA controller? Okay, so let's do Python get voltage.py. Okay. Did anything happen on the scope? While true, do that sleep 0.1 done. Okay, so now we have a stream of voltage readings coming back, and it looks like we are seeing, here we go, look at that, hang on. Yeah, we're seeing transactions happening on the bus. So let's just capture one. Go into single shot mode, and boom, there we go. So there we have, oh, look at that. That clock line, the data line looks terrible. Or am I on a different voltage scale? I don't think I am. Ooh, you could hear the turbo blow off then as it went past. So the yellow trace that you can see there, that is the clock line. The blue one is the data line, and you can see how small the excursion is, the peak-to-peak voltage on that, on the data line. So clock is, let's zoom back out again, bring it across here. Do I have this the right way around? Yeah, I suppose I do. So what I could probably do is actually just patch a resistor, patch a pull-up resistor onto this line externally and make it a stronger pull-up. Let's do that. That sounds like a splendid plan. Because it means I don't have to open the test-o-matic and we can see what's going on. But first I need to find an appropriate through-hole resistor out of my little random pile of bits and pieces that I have here. So it is oscilloscope time, not oscilloscope time, it is multimeter time. I've got a whole bunch of miscellaneous...
Henrik Ostrov said, can the oscilloscope decode a road now?
That's a good question. That is a good question. I'm not sure if this one has I2C. Let's see, decode, not parallel. Oh, it does. It's got I2C. There we go. Yes. Channel 1 is clock. Channel 2 is SDA. SDA bus status on. Yes. Okay. So now decoding is on. I don't know if we need to do that again. We're not seeing any values coming up. I'm just going to move this out of the way a fraction. I would have expected to see something based on this, but it could be that it can't decode it because the signal excursion is too small. The volt peak to peak on blue is tiny. It's like 300-400 millivolts. That is ridiculous. So that is what I'm hoping to improve with the with this resistor. Okay, getting back to here, I want resistance range. Sorry, you can't see what I'm doing, so it's not particularly exciting, but what I'm doing is just checking for a resistor in a vaguely sensible range. That's a 10k, that'll help. It's already got a 10k pull up on it, so adding another 10k in parallel takes it to about 5k, which is in the ballpark of what it should be.
Said, try to zoom in.
Try to zoom in? I will. I will, Henrik. That's another 10k. Yeah, okay, so I've got a couple of 10k resistors here. Let's go for overhead. I'm going to drop these out, drop that out. These are 10k resistors, and I want to connect them between data and ground, like that, and between clock and ground, like that. And now I can put the scope probes straight on here.
Said, check the 1x, 10x switch on the probe.
Oh, good point. Good point. They are both on 10x. Yes. And those channels should both be set to 10x. Oh, come on. Trying to get it to sit here properly. All right, run. Okay, that signal has definitely improved. Look at this. The actually, that was acting like there was no pull up at all on the clock line. That's really interesting. Okay, I'm going to take the clock back out of ground and just leave it floating with the... Oh, you couldn't see it. Damn. That. Okay, so this is what we can see now. And I'm just going to run this again without... hang on, why aren't you capturing anything? Why? Oh, it's because that wasn't in properly. All right, single mode, single shot. Yeah, why is this working now? I was definitely not getting that result before. Okay. Color me confused. But still, I'm going to put that 10k pull down. Oh, hang on, what the hell? I'm connecting it to as a pull down. I should be connecting it as a pull up. Is everybody in the chat shouting at me for right now? All right, so I'm going to pull data to 3.3 volts. I need to turn on the 3.3 volt rail to the device under test in order to energize that line. Where else? So I've got 3 volts through there, but I don't have a... Okay, I'm going to be super dodgy. I'm just going to shove this into the hole without having a header in there. And then I'm going to do the same with this one. Shove this into SCL and shove it into the 3v3. All right, so why did that start working when I added a 10k pull down? This whole thing is a bit of a mystery. All right, so now we've got, assuming these dodgy connections work, 10k pull-ups to 3v3 on both SCL and SDA. So we'll run the scope, and are we getting anything? Yes. All right, let's capture a single frame or packet, or whatever the terminology is in I2C land. Okay, now we are getting a clock signal. I'll just turn off channel 2 temporarily so we can see the clock. And that is the I2C clock. And you can see there is a there is a long low at the start. What time base are we on? I'm just going to align that with that point. We're on 5 microsecond time base, so that is 10 microseconds for that first long low pulse, and then 5 microseconds high, 5 microseconds low, 5 high, 5 low. So I'm going to cheat and get it to tell me what the frequency is. Frequency 100 kilohertz. Okay, so we're running a 100 kilohertz I2C bus here. It says it up there, not that you'd be able to read it, but right there it says freak 100 kilohertz. All right, now turn channel 2 back on. I'm going to turn channel 1 off. And this, I'll zoom back out.
Henrik Ostrov said, can you try to decode it next if you can on the scope?
Yeah, maybe, Henrik. I might be able to. So that is the data line, which is now making a hell of a lot more sense. So this is basic. This was acting as if the data line did not have a pull-up on it at all. Not just one that's too weak, but like it didn't have one at all. And that would explain why the signal was not getting through the level shifters. So this is interesting. Now that signal is kind of horrible. Actually, it's not that bad. I don't know what's going on here. Like with this little peak, it's like there should be a bit there, but there's not. But also, I've just, as you've seen, I just shoved the resistor legs into the holes in the PCB. They're not plugged in properly to anything, which is, and also I was holding it with my hands and moving it around, so that's probably why there's this noise. But you can see some overshoot. If we zoom right in
Scott
on
Miller said,
this,
faulty resistor or bad assembly?
most likely bad assembly. I always tend to blame myself, not that. So let's zoom in on the voltage range. So we're on the 1 volt range, which means we're getting around 2 volts excursion vertically here. And yeah, so what else can we learn from this? All right, we're seeing that the falling edges are quite steep. That's good. We got a little bit of noise on both the high and the low. We've got some overshoot happening on each of the, excuse me, on each of the falling edges. I will bring it up for your viewing pleasure. There we go. So
Scott
we've
Miller
got,
said, much like the issue with fake Chinese chips, now fake Chinese resistors.
yeah, I'd be very surprised because resistors are not really an item that's worth faking. They're so cheap, there's no value in it. No value in trying to fake them. It'll be my screw up. I absolutely guarantee it. It'll be my screw up. Okay. Zooming back out a bit again. And we'll turn channel 1 back on. Oops. There, get rid of the menu. And yeah, doesn't matter if they're not aligned. All right. Zooming in. What's our clock signal look like? You can see a little bit of a curve off on the rising edge of the clock signal, but otherwise it looks okay. And the falling edge looks perfect. Very, very slight overshoot. Nothing like the overshoot that you can see here. This is on the data signal, but the clock signal seems to be very clean on the trailing edge as it goes from high to low. So high to low is where it is being driven. So this I2C is like an open collector type system where the voltage tends to be pulled, it's biased towards the high state by the pull-up resistor, and then when it is asserted by a chip that is connected to the bus, the chip essentially shorts to ground, so it pulls the level down. So when we are looking at the transition here, so where the signal is high, it is being held high by a resistor.
Scott Miller said, clock currently has 5K pull-up. Data only has 10K.
Yeah, that is quite likely true. Thanks, Scott. So yeah, if the data pull-up was not missing entirely, it's now only the 10K that I've added. So in this high steady state, it is held there by the resistor, and then at this point, one of the line drivers in one of the I2C chips, in this case it would probably be the Raspberry Pi, is turning on its low side, like its driver, its open collector driver, pulls the voltage down to 0 volts and it holds it there. And then if we scroll along a little bit, at this point, you can see this is where the I2C driver releases the line. So it is no longer pulling it to ground using the transistor. It lets it go, and the voltage can then return back, being pulled up through the pull-up resistor. So if so this rise here is going through the pull-up resistor, overcoming the capacitance on the bus. And it's starting to trail off, you can see, which is why it's got that, let's zoom in, whoops, not that one, wrong channel, which is why it has that trailing off just here. It's a rounded edge. It doesn't go straight up and then straight along, which is what we would hope to see if this was a super clean bus with good strong pull-ups. But yeah, okay. Now, what would be interesting to see is the signal on the other side of the level shifters. But before doing that, I'm just going to hit that back into run mode. Oh, and zoom back out. So that we can see some. I'm going to zoom way out. You can see how irregularly it's happening.
Scott Miller said, never seen an actually square wave in my life.
No. It's like an ideal diode. It's the thing that you dream of, the perfect square wave. But yeah, it doesn't actually happen. So I think that signal is probably a little bit better now. But so I'm going to kill that, and I'm going to do I2C detect minus Y1, and let's see what we can see on the bus. We can still only see devices 2021 and 4041 42. We can't see the other devices. So that might be that. Hang on, I'm going to unplug the scope probes, pull them out of the picture, and I'm going to put I've actually got my hands now on the resistors holding them in place because I have a feeling that the connections are dodgy. Alright, so we're still not seeing anything on the bus apart from those devices which are on the 3.3 volt part of the bus. Sadly, I think the next thing to do is to pull the test-o-matic apart and probe on the 5 volt side of the bus, and also figure out what's going on with these. Maybe I'll chuck another couple of resistors in here in parallel with these 10Ks, like put another 10K laid on top of this one. I really should have made this like a 4K7. Don't know why I didn't. Just brain fart moment. So I could either swap the resistors and make these 4K7, or I could just lay another 10K on top of it, which puts them in parallel, and then we end up with effectively 5K resistors. Or I could put like an 8K or something in parallel. Scott
Miller said, measure the existing pull-ups.
Yes, I will do that and see what's going on there. Yeah, and Stephen W says only 2 volts high. Yeah, yeah, there is definitely something odd going on this bus. But it's interesting to have seen that on the scope and see that the data line was essentially like following the clock line until I added that external pull-up resistor. So I think it was just floating. That's why it was... In fact, let's go back to that and see if I bring this back. Let's go... You know, one of those classic situations of you have a fault, you change something, the fault goes away. I want to bring the fault back. I want to see the fault happening again. So, back here. Yes, that view will do. Okay, so you can see the scope, you can see this. I'm going to take these pull-ups back out and add ground back in. So we've got our ground reference, then we need SCL and SDA, and I want to see that again because I think I have a kind of explanation for what's going on. All right, now clock will make channel 1 because that's how the decoder is set up. So we're still not seeing, I wasn't seeing values on the decoder on the scope. Yes, okay, now.
Ostrov said, does the circuit even works where is the other resistor on the MOSFET, or whatever it is like, should it have a voltage divider sort of?
I don't know what you were saying. I will read your comment in a second and try to parse that. Okay, so what we're doing now is 10 times a second, approximately. We are doing a bus transaction, and we have we have these. Okay, so let's now, we'll normalize the voltages, bring these down to here, and let's capture a single transaction. Okay, so now we've got a single I²C transaction, and the data is actually looking like it should now. Well, the voltage is wrong, but you can see, now previously what we were seeing was that the data line was going up and down. Essentially, it was going up in synchronicity with the clock. So the clock up here is the yellow, and we were seeing a whole lot of activity on the data line. It was not showing proper data. It was like it was just having induced voltage from the clock line, which is what would happen if the pull-up resistor was not there at all and the line was just left floating. So that does make sense. But now we're not seeing it. We are actually seeing data on the clock line, although with the voltage being rather screwy. So we're on a 2 volt range, we're on a 1 volt range on channel 1, we're on a 2 volt range on channel 1, on channel 2. So, okay, so we're on the same voltage range. That is a bit, yeah, it's about 2-ish volts on the bus, which is low. So why is it sitting? Oh, hang on, no, max is 3.36 volts. You won't be able to read this, but up here max is 3.36, min is 920 millivolts. So it's only pulling down to just over a volt. It's not actually pulling all the way hard down. So 0 volts is down here where the ringing is happening. That overshoot is pulling down to 0, and then it's bouncing kind of back up to just under 1 volt. That might be an effect of the level shifter. Interesting. Okay. Let's do that I²C detect again. Okay, so we're definitely not seeing it. All right, now, what other comments were there before I start? Jordan, you made it. Oh yeah, Stephen W is just pointing out he's pointing out what I was just saying. So he was already on the case. Stephen said your low isn't going low. Low is approximately 0.8 volts. Yes. So that's what we can see on the screen here now, where my cursor is jiggling. that is nearly a volt at the low point. And where these overshoots happen, that is going down to right there, that is about 0 volts. Up here, that is about 1 volt. This is 1 volt scale on the scope screen at the moment, with the yellow being that little flag on the side. That is showing where the 0 volt line is for that axis, or for that trace. Yeah, okay. So we still don't know. Yeah, Scott says, leakage in the level shifters. Maybe. So it is quite possible that what I need is a better level shifter solution. And yes, the other thing, okay, so backing up a little bit, looking at the bigger picture, why do we have these level shifters? What's their purpose? All right, so the Raspberry Pi is running at 3.3 volts. And so we've got an I2C bus coming out here at 3.3 volts. Now for some devices that's fine, because I can run them at 3.3 volts. For example, the, where are we? Here? Yes, here. For example, the I/O expanders, I'm running at 3.3 volts because this I/O is all at 3.3. That's my goal. So that is fine. I can connect them directly. However, the problem is with the ADCs and the DAC, because I want those to run at 5 volts and to be able to read a 0 to 5 volt approximately, minus a small margin, input range. So I can't run them at 3.3 volts. If I could run these at 3.3 volts, that would make things a lot easier, because then I wouldn't need the level shifters. So one of my questions is, do I need the level shifters? Because it is possible that these devices will accept 3.3 volt I2C without level shifting, even if they're running at 5 volts. Now, technically, that is out of spec, but it may just work. So one of the things I could do, oh, okay, Scott just had a suggestion, which is a very good one, and it is along the lines of where my thought process was just going. So Scott said, here's a thought, pull off the level shifters and take another look at the 3v3 side of the signals. And yes, that is a good idea. So that would be isolating the 3 volt rail, the 3 volt I2C bus from the 5 volt, and taking the shifters out of the equation. And see if the signal looks better, like see if we get full voltage rail excursion.
My question was in the lever shifter between the 3.3 volts and the pin. Should there be another resistor?
I don't think so. So Henrik's question was, should there be another resistor here in the level shifter? And I do not believe so. So we've got the MOSFET using the body diode trick on the MOSFET as to be able to pass data bidirectionally, and using pull-ups to the 2 voltage rails on either side. So these pull-ups should be lower values. They should be like 4K7, but they're not. But I don't think there needs to be another resistor. All right, so Scott's suggestion is pull off this transistor. What that effectively does is cut the line between the 3.3 volt and the 5 volt signals, and allows the 3.3 volt to operate in isolation, not influenced by anything else. And then we'll see if the signal gets better. Does it then go all the way to 0 volts? And then the next thing to try is to jumper across between the source and the drain connections where the transistor used to be, so that there is no 5 volt SCL. It all just becomes 3 volts. and see if those ADCs will work. We'll see if these suddenly appear on the bus. They may be happy talking to us at 3.3 volts, even though they're running off 5. Stephen has a comment, and yeah, so Stephen says, remember to also
Stephen
pull.
W said, don't forget to pull the 5V pull-ups.
Yes, that is a very good point, which I would have forgotten to do at the point of bridging that across. So Stephen, thank you for mentioning that. The explanation of what Stephen is saying is, if in fact, I'm going to do it on the schematic here. If I remove this transistor from the PCB, and then I bridge across this here, and just put a jumper across on the PCB, what this would be doing is tying the buses together. However, we also end up with a pull-up on this side going to 5 volts, which would be trying to pull the 3.3 volt rail, the 3.3 volt data line up to 5 volts. And that would not be good. So I need to remove that as well. So effectively what I need to do is do that, delete those 2 parts, and then bridge across from here to here and see if we can communicate with the things. Wagon Load says, look at my last comment. Okay, where is Wagon Load's comment? Would an I2C opto-isolator work as an I2C level shifter? Yes, it would. So the proper way to do this is with a level shifter line driver. And
Smoke, smoke, smoke.
yes, Scott, we can hope. So Tabray's asked, what's the RDS on the IO3 SCL pin and the VDS sat on the FETs? Off the top of my head, I do not remember. I looked up, so the it's VDS sat. I thought it was the RDS on value on the FETs that is the critical thing, because the RDS on must be less than the difference between the 2 buses. So if I undo a whole bunch of stuff here, so if I put that back to where it was.
Henrik Ostrov said, look, Killer Geek comment.
Killer Geek comment. Okay, where is that? Ah, yes. So Killer Geek is suggesting some level shifters like the TCA 39306 or NXP PCA 9306. Yeah, that's right. That would be a nicer way to do it. And if it turns out that I do need to keep level shifters in here, I should probably put them. This is a nasty hack. Doing this with a couple of MOSFETs it works, but it's not great. It's better to use a dedicated bus level shifter if possible, because you end up with squarer edges and yeah, it's just generally better to do it the right way. I've done this many times before and it does work, but it's not ideal. So where was I? Tony Smith said, some experience with running MCP at 5 volts without level shifters in a factory test set. They work but glitch fail about once per day. I now use the exact level shifter with a 2N7000. Okay. J. Drummond said that MOSFET level shifter is the example given in the I2C specification. Yes, it is very. It is a very common way to do it. Jack Stack said the level shifters are effectively that circuit inside with a buffer anyway. And Jay said, so it should be good. Yeah, it should be. But the line drivers are, yeah, they still do a couple of extra things. It's not just a MOSFET in a package. They've got a couple of other little things that make them a bit nicer than doing it this hacky way. That's right, that's what I was saying. So the RDS on value for the transistor, for this trick to work, the RDS on has to be smaller than the difference between the voltage rails. I think that's the rule of thumb. So in this case we are translating between 3V3 and 5, which means there is a 1.7 volt differential between those two rails. So the RDS on for the transistor has to be less than 1.7 volts. And for the 2N7000, it is less than that, I think. I can't remember the numbers. It must be like a couple of years since I looked at the, well, maybe not that long. It's been a long time since I looked at the data sheet for the 2N7000 MOSFET. But I think the RDS on value is below the delta between these two things. So where was I? Where I am is procrastinating and putting off actually opening this thing up and dealing with these level shifters. So I am I am trying to put off disassembling this thing. Okay. Yes, Scott is about to tell me what I was doing. Oh, Tony Smith said, have 80 of these level shifters and have been running 24/7 for 3 years without any problems. Yep.
Scott Miller said, you were planning to pull those transistors.
Yes, that is what I was going to do. What's the time? 11:42? What? Okay. Gavin says, out for fuses the right size. A bit of Siggy paper will do. Electronics for bogans. And Killer Geek said, if they still fail, then check the bus capacitance and inductance. If those still hold up to the spec, and those type of level shifters are also sensitive to external interference. Okay, so I think my goal in the next 18 minutes is to disassemble this. In fact, what I need to do before I slide across here, I kind of got to turn it off, haven't I?
Miller said, overtime is for bodging, as usual.
Yeah. What am I doing? I'm looking for, where is my terminal? Oh, it's hidden by Fusion. There it is. Let's just run that again for the hell of it. Okay, so that's what we are seeing on the bus. We are only seeing those devices on the 3v3 side of the I2C bus. So the tester has now shut down.
Said 16 minutes now.
Yep. Okay, I am going to transition to the bench, which means I am not going to be able to easily read the chat, which means please make liberal use of the TTS so that I can hear you instead of see you. Power, turn off the power supply. Power out. And all right, where do I begin with disassembling this thing? It's been weeks since I've been messing around with the mechanical aspects of this, and I only half remember how it goes together. All right, I need myself a screwdriver. That is a good start. Let's see what I've got. This one should do. So I think I start by taking off the side casing.
TTS bork.
TTS bork? No. Got to keep the TTS running now that it's mission critical. It's gone from being fun to being, ooh, we need this. Okay, so this is what this is one of the flaws with the design at the moment, is the entire thing. Yeah, it's hard to get to that PCB, this board right here, because it's inside everything to get it out. In fact, I'm not sure if I'm gonna have to no, I shouldn't have to undo that. I've got to disassemble a lot of stuff just to get to that board. Oh, I'm gonna have to take that out as well. Oh, maybe? No, I might be able to just, yeah, okay. All right, less talking, more doing.
Henrik Ostrov said, Henrik Ostrov said, Henrik Ostrov said, Henrik Ostrov said.
Really? Henrik, what did you say? You said. Yeah, I think I might be able to do this, actually without removing the PCB from the chassis. That's my goal. I don't want to have to do that. So take the side off. And so now we've got access in through here. But if I get this deck plate off, I think I can do everything that I need to do just by tipping the thing up. In fact, I wonder if I can do it without removing the deck. I probably could, but I'd be in danger of damaging this. So I'm going to remove the deck anyway, so that I can get to, because I only need to get to the top of the, yeah, around here. I only need to get to the top of the PCB. I don't need to get to the bottom of it. And I'll solder on a couple of jumper wires. Now this is a situation where having a 4-channel scope would be really useful, because what I could do is put 2 channels on the 3-volt part of the I2C. Oh, to get that out, I'm probably, oh, can I do this without breaking everything? Oh, I might have to take the back panel off. I think I will. Yes, I don't want to risk breaking it. Yeah, anyway, that's right. That's what I was saying. Two channels from the scope going onto the 3v3 I2C bus, and 2 channels on the 5-volt, and we can see the differences. And that would actually be a valid use for a 4-channel scope, which I do not currently have. My current scope is 2-channel. That, and then that comes out. And now we have access again to the PCB. All right. So I think what I'm going to do is start. I want to measure this without changing anything. Oh, hang on. Ooh, I just saw something.
I now have worked out how these twats did the heating on the coffee machine. So now custom coffee machine it shall be. Whoa, it needs a clean G's.
Ooh, Henrik. Say no user serviceable components inside. Okay. I'm not quite sure how to say this, but one of these chips has explodified. It's like the smoke has come out. Which one is it? Is it one of the ADCs or is it the DAC? I think it's one of the ADCs. It's the chip that's on the right. So let's have a quick look in Fusion and figure out.
5 months. Wow, if that's a new thing, it's crazy.
It could well be that there is nothing wrong with the level shifting. It could be that one of the chips has exploded. It is this one right here, which is on the bus, which is breaking everything. Scott says, I see an upcoming mechanical design change. Make the deck removable without tear down. Yeah,
that might explain the glitching.
That could well explain a whole lot of things. So this chip right here, unfortunately I can't get the microscope onto it because of the enclosure, but I'm going to see if I can get this off.
Boom.
Chip go boom, yeah. Okay, it's one of the 1115s. Let's see, is there anything odd about this? So we've got vSense, we've got SDA coming
J Drummond
here.
said, at J Drummond.
We've got 5-volt rail. There is 5-volt pulling through to there. That's SCL going through. We've got
J Drummond said, at J Drummond.
At J Drummond. Where is it? Where was J Drummond's? Maybe the 5-volt rail is connected to drain. There may well be an assembly fault on here. Like there could have been a short, for example, a solder bridge between a couple of these tracks. It could be, yes, drain. SDA could have been bridged to 5 volts, and that has made this go boom. Whew, all right. That is interesting. All right, I am going to remove that chip, and then let's look at the signals. Let's see what's going on. I feel like I need a drink. I really need a drink, but I think I can hold on. I can make it out of the desert of this live stream. Okay, sorry, I'm pausing because I'm thinking of a plan. What am I going to do here? What am I going to do? I've got to get that chip off, but you can see from your angle, so you're looking straight down on it. It is down underneath the edge connector. If I angle it right up like this, it's there. It's not that easy to get. If this PCB was sitting flat on my workbench, like in that orientation, I would be able to get to that not too badly.
Maybe a strong drink. You'll have a shot of Crown for you.
But I've got all of this structure around it which gets in the way. Now, before I do anything, before I touch it, I want to see if I can get the microscope on and see what's going on with that. All right, let's try this. I don't want to destroy the evidence, basically.
At Killer Geek.
Okay, what did Killer Geek say? Unscrew PCB. No, but that's what I'm trying to avoid, because the screws for the PCB go through they go through here, and then there are standoffs, and it's screwed on the other side of this vertical plate, and that is right inside there. So to get to that, I've got to take off this whole front assembly, and putting that in with those standoffs is a bit of a pain in the patootie. So let's go gadget microscope. And I'm going to see, this is going to take some jiggling, I think, but I'm going to see.
Said, use a hammer. It always works, lol.
Yeah. If I can get this into a position where we can see what's going on. Oh, that's the USB connector, so I need to move it that way.
It's designed like a Dodge.
I'm kind of holding this off the edge of the bench at the moment in order to get it into the right place. But do you see what I'm seeing? Look at the state of that chip. So that one to the left, that is the DAC. That one in the middle, that is an ADC. And that one is another ADC. And this ADC has gone kablooey. Now, let's see if...
Henry Ostrov said, but now it needs a bodge.
Yeah. Okay, I'm going to get some more zoom happening so that I can try to spot any solder bridges or anything weird going on. I'll try to get focus. It's a little bit dark. It's very hard to focus here. I'm holding this off the edge of the bench to get the right angle. I don't see any solder bridges. There is nothing jumping out at me saying there is a mechanical assembly fault here. So what I'm going to do is, yeah, but that chip is definitely explodified. You don't really get you're not getting a 3D view through the camera, not like I can with the stereo eyepieces. But the top of that chip is not just discolored, it's actually buckled up.
Do I see some flux?
A little bit of flux, not much. The whole chip has bulged up in the middle. That has been some serious smoke emission. Right. Back to... I'm going to take it off. I couldn't see any solder bridges.
Henrik Ostrov said, are you 100 sure it's 5 volts chip, not 3v3?
That's a very good point. That is a very good point. Henrik, thank you for pointing that out. I am going to have a look at that. Well, maybe while I'm doing this, someone can look up the datasheet for the ADS 1115 and see what its voltage rating is. I am reasonably confident that it is, in fact, a... How am I going to do this?
It's to become a flux capacitor.
Yeah. I'm trying to do this in a position where you're going to be able to see. What can I use to prop it? Maybe solder? Yeah. somewhere like
Hangout
that.
Ostrov said, if it's 3v3, then you gonna fry another one.
Yeah, I'm not going to put another one on, I'm just going to take this one off, and then I want to see if the other devices appear on the bus and what happens to the signal.
Mitchell R said, input voltage range max version 5.5.
Nice, thanks Mitchell. Yeah, I thought that was the case. I was pretty sure, whoops, I was pretty sure that these ADCs and the DAC are 5 volt capable. Alright, so the chip is off. I'm going to just clean up those pads a little to make sure there are no solder bridges and check it again under the microscope, because I can't actually see. I'm doing this at a very strange angle, working almost blind. Can't see what I just did. So let's
Wagon Load said, at Wagon Loads.
let's put it back under the microscope and I'll see if I remove those solder bridges. Where is it? There.
Wagon Load said, at Wagon Loads.
Alright, I will check out Wagon Load. So this is where the chip was that explodified. Have I removed any possible solder bridges? I think so. Yeah, I think that's okay. Now, next step is power it back up and try again. But before I do that, you see over here where the level shifters are, I am going to, well, is that a, no. Oh, I thought there was an open joint there. But no, there's a solder fillet. Those 10K resistors kind of look okay, but I'm going to measure them just to be sure. Yeah, alright. I don't know whether you could see any of what I was just doing.
Superhouse TBT ADS1115 has an address line so two of them can be on separate I2C addresses. They look wired the same, which means they were on the same address. Scott Miller said, next step, watch the other one go boom.
Alright, now, the address line should be different. Where is the address? Yeah, there it is. Okay, so the difference is pin 1, hang on, you can't see what I'm looking at. They are wired differently. So this is one of them, this is the other, and you can see that pin 1 here is pulled to ground. Maybe that's the problem. Maybe that was the problem. And pin 1 here is pulled to 5 volts. So what is the pin out on the ADS 1117? What is pin 1? Okay, I need a pin out. I'm going to 1115. Pin out. What is pin 1? Is that the address pin, or is it the power pin? Oops. Yeah, pin 1 is address. So it's pulled to ground on one of them and 5 volts on the other. Maybe it shouldn't have been pulled to 5 volts. Maybe that was the problem. It was hard pulled to 5 volts, like not through a resistor. It was just like hard tied to 5 volts. So let's see. Rookie mistake. Yeah. Maybe it was a problem. Anyway, what I'm going to do now.
I said rookie mistake.
Yep, because I'm a rookie. Oh, hang on, no, that one was tied to ground. On the one that went kaboom. All right, what I'm going to do is solder.
Eric Ostrov said, you forgot Alex turn on fume extractinator. 5,000 there should be a resistor, I think.
I'm going to solder a jumper wire onto, whoops, not that, I want that. I'm going to solder a jumper wire onto the 5 volt SCL and SDA lines so that I can attach the scope probes. Alright, That's my next thing, because I want to be able to see what is going on those buses. Then I'm going to power it up, and it may be that scanning the bus, those other two devices are now visible. We shall see. Oh, Stephen said address pin is input only, so pull up directly to 5 volt shouldn't be an issue. Yep. Okie dokie. Now, let's have a look. What do I need? I need a couple of jumpers. And what do I have? Aha! These will do nicely. I will attach a couple of jumper wires.
Check new members on TTS.
Check new members? Okay. Okay. Who has joined? Who has joined? Oh, there are a bunch. Some of whom I've already been chatting to. So, Killer Geek, welcome. Wagon Loads is here. Jordan is here. Some call it fun. Tony Smith, Gavin Jackson, Dodgy has made it. Paul Schultz, welcome Paul. Hey, do I get to see you in Adelaide in January? I hope so. Graham Brown is here. Joe Gold is here. Okay, so yeah, Paul, are you going to be at Everything Open in Adelaide in January? I have not yet booked my ticket, but I am planning to go, so I hope that you are there so we can
Henrik Ostrov said,
say hi.
Scan first the time is turning up. Some call it fun said, thank goodness you didn't glue the case. I think you got full access in less than 5 minutes.
Yeah, I am actually surprised. The access is remarkably good with the side off and the deck off. And so it wasn't too bad at all. Now, please excuse this noise. Yeah, in recent years I have started wearing gloves a lot more while doing this sort of thing. Here it goes again. Because it really isn't a good idea to be sticking your hands all over leaded solder constantly. I don't always wear gloves, but I lean towards doing it far more than I have in the past. It used to be a rare thing. Now it's a much more common thing. Now, how do I prop this up? Maybe that. Prop it on the solder and feed the solder out from underneath it. That one. This is awkward. This is slightly awkward. To be honest, not gonna lie, as the kids say these days. What? Who? What? What was going on? To Braze.
Mitchell R said, wait what, we aren't supposed to lick lead solder. Well.
Yeah, you're not supposed to lick it. Definitely not supposed to lick the solder. To Braze is now a gold supporter. Thank you to Braze. That is really cool. I appreciate it. Did I get that soldered on? Yes, well, the wire isn't falling off the board at least. Now, so we should have signals for the 5 volt side. Okay, and let's put the breakout board back in place because that will give us convenient ground connections. So, back to, I don't need that. Yeah, I'm not going to bother putting that USB cable back in place for now. I don't need it.
My leaded solder is frowned upon.
Yeah, you'll frown if you chew the leaded solder. Now, what am I doing? Okay, back to here. I need to get some signals. Signals. So I'm going to grab a ground off there. I am going to grab, I don't know which one is which, but I'm going to guess it and get it wrong because with a 50-50 chance, you get it wrong 90% of the time. And then, see, I'm good at statistics. And then power is the next thing we need. Power. Here. Here. Power in there. Turn it back on. And we have life. So then, once this is booted, I'm going to... No smoke coming out. Nothing that I can see. Okay. It is booting, booting, booting. Okay, that's enough of the gloves. And we are back to here. So...
Tabray's Malik said, if it's addressed, then the two chips will need different settings. Gout on one and VDD on the other.
Yep.
So
That's
not a mistake.
Yep, that's what they've got. Where am I? There, okay. So let's get back onto Testomatic. And what was I using? Get voltage.py. Okay, but first I'm going to do I2C detect. Look at that! There are new devices. Look, look. We've got hex 49 and hex 60. So we now have the DAC and one of the ADCs has come to life. Yes. Say Q. Say Q. Why is Say Q working? I don't get it. Okay, so all right, let's have a look at these signals. Let's check out the level shifted signals. We'll move that over to there and run the scope, and I'm going to I'm going to go back to doing this. Here we go. Okay, so now we are running 10 transactions a second through the bus, and you can see that there is a whole lot of activity going on. Now, let's...
Mitchell R said, say says name vs say, which is say quiet, i.e. no name.
What? Ah, okay. It's say quiet. Right. That's clever, Mitchell. Thank you for the explanation.
I will ask, why did the chip fry? What did happen with it?
Yeah, we don't know that yet. We do not know. Okay, so, all right, we'll get back to that. We will get back to that. For now, I want to investigate this. So we are seeing...
I will ask, why did the chip fry? What did happen with it?
Yeah, we'll get there. All right, let's capture a packet. We'll single shot that, and we'll grab a single I2C packet, and let's have a look at what's going on with the signal. It's kind of ugly, but functional. All right, now what it looks like is blue is the clock, so channel 2 is the clock, and yellow, channel 1, is data. So of course, with a 50-50 chance, I got it wrong, and I got the signals mixed up. But you can see here, what have we got peak to peak? So max 4.96 volts, min minus 240 volts. We are getting full scale excursions here. And this ringing is actually undershooting the rail. I don't know why we got that ringing on there.
I said it only once IDK. Why did it repeat itself?
Yeah, I don't know. It does that. Okay, so we now have nice full scale and not totally ugly I2C signals on the 5 volt version of the bus.
I said it only once IDK. Why did it repeat itself?
Henrik, I don't know. This is happiness. This is good. All right, so we've got...
I said only once IDK. Why did it repeat itself?
Stop that. Stop that. 3 times. Yeah. Okay, so we've got, same as before, we've got a rise with a little bit of a knee.
I said it only once IDK. Why did it repeat itself?
Is TTS has had more caffeine than Mitchell has. Yeah. So we got this rise here with a little bit of a curve at the top. We've got a nice sharp...
Said it only once IDK, why did it repeat itself? TTS has had more caffeine than Mitchell has.
Okay, pull looks not strong enough. That's right, so Killer Geek says pull looks not strong enough. There, we need a stronger pull-up resistor.
TTS has had more caffeine than Mitchell has.
I'm going to hit mute in a
I said
second.
it only once IDK, why did it repeat itself?
Is this a Rickroll?
TTS has had more caffeine than Mitchell
Here we go. That's it. I've muted it.
TTS has had more caffeine
Hang
than
on.
Mitchell has.
Now I've muted it. Right. Okay, so Jay. All right, so Jay has some interesting information here. Jay said, you were concerned with the pull-ups not being small enough. Range of pull-up for standard mode, 100K, so 100 kilohertz, which is what we are running. I2C is dependent on capacitance. Capacitance of bus equals 50 picofarads would be 24K pull-up. 400 picofarads is max allowed. Yeah. Okay. Subcaller Fun says, it has become sentient and it's angry. Yes, it is emergent behavior. Yeah, okay. So I am not at all unhappy with that. Like this waveform that we are seeing here, considering this is on the far side of the level shifter, that's actually okay. I think going to 4K 7 pull-ups instead of 10K would make that rise time a bit sharper, but that is perfectly acceptable. So we now have working I2C on both 3.3 volt and 5 volt. Now, what's going to be interesting, this is going to be the interesting thing, I am going to put this back on the 3.3 volt side, and we'll see if we still got that 2 volt excursion instead of 3.3 volts, which is what we should be getting. So, where are my jumper wires? Where did I put them? They're right here in front of me. All right, so what I'm going to do is switch back to, I'm going to put these onto the 3v3 bus. Oh, so I'm going to put channel 2 on data, which is that one. And I'm going to put channel 1 on, who's messaging me? Oh, my sister. On clock. All right. Let's see what we are getting. If we come back to here, I'm going to put it into run mode. Hang on, I've got a cough. Ah, okay. Oh, Tabraze says ringing might just be poor grounding on probe. Yeah, that's quite possible. Let's zoom it back out and single shot it. Capture, boom. All right, we've got ourselves a capture. What have we got? And now we have full rail to rail I2C. That is cool. Okay, so, and if we zoom in the voltage range a little bit to get a bit more of a view of that. So blue in this case is, which one is it? Yeah, so blue is data, and yellow is clock. And the signals look quite acceptable. I am happy with that. And we've got the full, so this is 0 volts, and this is 3.36 volts. It's reporting up here as the max. So yeah, we are spot on. The bus is now working again. Henrik, yeah, I've muted TTS because it was going crazy. So the says that people are doing are not working. Henrik said, can you add a new chip quickly? I want to see, does it work or still fry itself? Jay said, I watched Phil's Lab I2C video and learned a lot. Oh, cool. I should check out that video as well. I want to learn a lot. Scott said, all of this chaos and it was one balked chip all along. Yeah, but we still don't know why the chip balked. Wagon Load says, can or do you need Zener diodes to clip the signal overshoot? I don't think so. And Wagon Loads asks, can you get at your thermal camera to see if any chips are getting hot? I could, but that would take a bit of time, and we're already already at 2 hours and 16 minutes. I'm going to unmute and see if TTS is going nuts. That's it. Okay, TTS is now live again. We'll see what happens. Okay, so Jay is dropping some knowledge here. So Jay said 400 picofarads is max allowed. That's the bus capacitance. And then Jay said 3K for a 400 picofarad bus. Don't go below 3K. And rise time should be below 1000 nanoseconds by spec. Okay, so I think we are well within the 1000 nanoseconds range there.
Test 1, 2, 3.
Okay. And Henrik said, so can you add a new chip? Oh, Mitchell said, made a change for dupes. Let's see if it fixes it. Testing in production, just as all good site reliability engineers do. Echo? Echo? Come on, Andrew. Say echo. Andrew says echo. It'll get there eventually. Oh, Dodgy said, leave it muted, please. Henrik wants to see the...
Andrew Brown said, echo.
And yeah, Henrik wants to see the smoke come out. Now, I want to know why the smoke came out in the first place. I'm kind of baffled about what's going on here. So let's have another quick squiz at this
I like
circuit.
seeing fried chips.
Fried chips. Deep fried chips. Oh, now you're making me think about lunch. All right, so what is the difference here? One of these fried and one didn't. It was, which one was it? U2 or U3? It was U2. Still don't know what I'm looking for. And where the nets have no name. Okay, I'll stop with the dumb music jokes. You too can can have these problems. Okay, so U2 is the one that explodified. U2 is this one, which has address pulled to ground.
Because it is lunchtime. Grown.
Yeah, it is lunchtime. It was this one with the address pin pulled to ground, pin 1. What did I screw up? You know, I do want to put a chip back on this and power it up while I'm still on the stream, because when chips explode, it never happens when the camera is running, and I want to see it explode live and let the smoke out. And I want you all to see it as well. So let's put a new ADS 1115 in place of U2, and yes. Sorry. I'm pausing because my brain is trying to find U2 jokes. Like I'm trying to work out how to incorporate Bono or, you know, something into it. No, okay. No more U2 jokes. You can all make U2 jokes. I will try to avoid making U2 jokes. Now, what am I doing? I'm lost. Lost, I tell you. Okay, I need to find my 1115s, which will be around somewhere, and put one on. But can anybody see a problem?
Stephen W said, where are the Vicence pin on the PCI connector? Any nearby 12V pins?
Ah.
John U2 are the best with the electronics.
Oh, thank you. It's a lie, but thank you. That is a very good point. Maybe it was a short through the breakout. Okay. In any case, because I am over time.
It's an edge case.
It's an edge case.
Paul Schultz
Yes.
said it's an edge case.
Yeah, Gavin. Sunday, bloody Sunday. Yes. Sunday, smoky Sunday. Let the smoke out. Now, while I'm doing this, I'm just going to leave this on the screen. Can anybody see a difference or a problem between the way these two ADCs are wired up? They should be, in theory, identical apart from the address pin. So pin 1 here is the address pin. It's pulled to ground on U2, which exploded, and it is pulled to 5 volts on U3.
Then the others should be fried as well.
If it was a short, not necessarily, Henrik. If it was a short on one of the pins, like one of the analog inputs, say hypothetically one of these analog inputs,
then the others should be fried as well.
Yeah, smell-o-vision, says Greg DeVille. Greg, you're here. It's an honor. So, yes, we need smell-o-vision. So if, for example, one of these analog inputs was tied to 12 volts by mistake, say the edge connector had bridged across, that could inject 12 volts into the ADC, which would go kablooey, and that would actually explain what's happening here, like why U2 has failed and U3 has not. Okay, so I'm going to have a quick look. All right. While I'm doing this, you have a look at that schematic and see if you can find my deliberate mistake. I see. So what am I doing? Sensors. It'll be in the sensors box, I guess. Temperature sensors, current sensors. Actually, those ADCs are most likely in the box for the Testomatic, which is up here. At least I hope they are in this box, because otherwise I don't know where they are. All sorts of interesting things in this box now. Weird little HDMI cables and USB hubs and bits and pieces. There's the notebook for Testomatic. Come on, edge connectors. So far, no little anti-static bag of ADCs. The other place they could be is in the clean room. So I might have to go and look in there in a minute. Where? Oh, this would be disappointing if I can't find the ADCs. There's the box from the barcode scanner. Oh, which reminds me, I was going to tell you more about the light box and doing the extraction of device serial numbers from the QR codes. These Jack Seck said, Angels 2 pinned to the ground. These two U2 references write themselves. Yeah. Gavin says, switch to in excess. Mystify me. Wagon Loads asked, did you have one of the chips on backwards? No, I did not. I actually checked that. Yes, go clean room. Thanks, Henrik. I will. I will keep talking to you while I am wandering around. So, no, that was actually something that I was thinking about, and then that's probably going to be noisy while I'm shuffling through anti-static bags. So before I took it off, when I was looking at it under the microscope, I checked the orientation and it did seem to be correct. Current sensor, EEPROMs, what else have I got here? Ooh, AT Mega 4809s. ATmega 1284s. Such a random collection of anti-static bags here. I wonder if it is in my incoming. Yeah, squeaky, squeaky shoes on the clean room floor. Is it in here? Regulators. So I'm looking at my little storage box of miscellaneous things kept in dry storage. I've broken the seal. SAMDs, NFC transponders, so many things. Opto isolators, CAN transceivers, CAN controllers. Where, oh where, are my ADS 1115s? I really want to let the smoke out on the stream. Maybe in semiconductors? Oh, I can I can hear that TTS is speaking to me from the other room, but I can't hear it. Not from here. No, it's not in that. It's not in that Enviro box. I don't know. This is annoying. Where are my 1115s? I'm going to go look in other places. Back in. No, there's an I2C redriver here. So I did a project recently for a client where we needed, for reasons that I won't get into right now. Oh, is that it? No. We needed to get I2C over about 12 meters in an electrically noisy environment. And so I ended up managing to make it work by running a very low clock speed, strong pull-ups, and I2C redriver ICs. So I've got some, hang on, I'll go back to them. What were they? PCA 9508D. It's a hot swap I2C redriver. I ended up using those, driving the bus really hard, and we got it to work. Through some really nasty testing too, like getting a mains lead. Oh, I won't go into that, I won't explain. It's kind of interesting, but Schmidt triggers, no, it'll, if I've got it here, it'll be fairly close to the...
Give TTS a refresh. Made a DUP protection in the UI, which should help.
Oh, okay, thanks Mitchell. I will... Nope, it's not in that box. Maybe... Ah, where? Where? Are they just sitting here on the bench somewhere? They should be in that box. Oh, someone just left a bit of rubber on the road outside. You could probably hear it go past. And whatever that was is turbocharged. Back to looking through the sensors box again in case I scrolled through it too quickly last time. Oh, there's an NAU 7802 ADC. That's a 24-bit I2C ADC. But that's not the one. Rotary encoder magnetic sensor. Oh, that's annoying. I wish I could find the chips. And we're over time. What have I done with them? What, people? What? Okay. Wagon Load says, can you check the voltages on the PCB before you solder the new ADC when you have the breakout plugged into the slot? Yes, that's what I did. So, isn't it? I thought that's what I did on the scope a minute ago, which is why we've got this. So this is showing the full scale, like we're going from 0 volts to 3.3 volts here. We're getting full rail to rail voltage on the I2C signals. Crispian says, my kingdom for a horse. Scott Miller says, whole reel of them just to the right of the Testomatic. Probably. Let's see. No. No. Those...
Ostrov said, can you grab it from another Testomatic?
No. So Henrik just asked if I could grab it from another Testomatic. And the short answer is I do not believe so. What is that? I'll clean that up later. I'm leaving crap everywhere right now while I'm doing the stream. I'm going to have to clean up afterwards from the mess that I'm leaving behind me now. Now, I am slightly surprised that it is not in the Testomatic box. It could well be that I'm simply not looking carefully enough. Where else? So I'm going to do it a little bit more methodically. I know I am way over time, but I would love to get this. More messages. I would love to get this fixed.
Crap everywhere. That's why you can't find them.
Yeah. It was actually reasonably neat and organized before the stream. What's in that? Oh, that's right. They're the fancy little right angle USB.
Pick and place machine.
Pick and place machine. No, I don't have. I've only ever bought like sample quantities of those parts. Just, you know, like 10 or something. Because I was just experimenting. I haven't actually got to the point of production of anything related to Testomatic yet. This is not looking good. It's not looking like they are in here. I've pulled most of the stuff out of the box. And I can't find it. It's a CAN interface. Nope. Nope. Well, that sucks.
Scott Miller said, how long ago, where did you actually assemble the board?
Yeah, where I actually assembled it was right here on the bench in front of me. So your MB...
Henrik Ostrov said, so MB your stock is empty.
What does MB? Oh, maybe. So maybe your stock is empty. No, well, actually, I wonder. Did I... That is a very good question, Henrik. I wonder if I used them all. I don't think so, though. I would have bought some smallish number, because they're not super cheap. Like, they're not mega cheap chips. It's not the sort of thing where I just go, oh yeah, I'll buy 100.
Scott Miller said, maybe they got knocked to the floor under the bank.
No, I would see it. I did a fairly extensive cleanup here last weekend, and the lab is actually quite surprisingly neat and organized. And I know, you're going to be saying that's my problem. That's why I can't find anything. Actually, I can find most things. But this.
Henrik Ostrov said, Scott asked how long ago you assembled it.
Oh, it was a while. It was a couple of months ago, I think. So, yeah, some significant time has passed. All right, I think I am going to give up on specifically searching for those ADCs and get a dev board to pull it from, says Killer Geek. Killer Geek said no dev board to pull it from. No,
Scott Miller said, never clean up the lab.
I
Leads to
might
confusion.
have an Old Testament board. No, I don't think I do actually. I've only got one other Testamatic board assembled, which was the previous generation, and that is currently in tester 2, which is in use in the clean room. So I can't pull it off that.
Said, you will find it after you kill the stream.
I know. Gerald, you are correct. That's exactly what's going to happen. I'll end the stream, and then I'll find the bag is sitting right here in front of me on the bench.
Ostrov said, go AMD rest. I think you maybe use them all, then can you check how much PCS did you order them last time?
Yeah, it would take me a bit to look it up. I'd have to find my order history. I do a lot of
Any Mule
orders.
said, can you move U3 to U2?
Ah, that's an interesting idea, Any Mules. So, don't know if you could hear that, but Any Mules just suggested that I relocate U3 to U2. So I basically do U3 minus 1, or U3 minus minus. I'm just having a look in my orders for, what was it, ADS 1115. No, not ABS, ADS. No, what if I just search for 1115? Nope. Can't find it in my DigiKey history. Oh well. They said that a while back while it was freaking out, while TTS was freaking out. Ah, okay. So I ask she who shall not be named where I put the ADS 1115s. Yeah. I am seriously considering relocating. Okay. Screw it, let's do it. Let's relocate U2 and put it on the footprint for U... Yeah, we'll relocate U3 and put it on the footprint for U2. So this, for reference...
Henrik Ostrov said, was it from DigiKey or was it somewhere else?
It might have been somewhere else, but it was most likely DigiKey. I get stuff from DigiKey, Mouser, and LCSC and other places, but for this I think I probably would have ordered it from DigiKey. Alright, so just remember, this is what we currently have. We know these ones, these are fine, these are on the 3.3 volt side of the bus. So we've got address 49 and address 60 is what is currently showing up on the bus. And if we go to Fusion, we can see that address 49 is this one here. This is U3. Now address 48 is U2. So what we should see after doing this migration is we should see device 49 is gone and we should see device 48 appear. Now I am going to... Oh, Scott says trace those vSense lines before you move the chip.
Scott Miller said, trace those VSE and SE lines before you move the chip.
Yes. Yes. So these are the 4 vSense lines going into U2. And so these ones, oops, these ones. And they are these 4 highlighted traces here. So you can see these come up to the edge connector. What signals are near them? Not very much. So we've got a ground right there. Pulling them to ground wouldn't be a problem. It would just see it as a low voltage input. We have a ground up there. We've got some more vSense lines adjoining it.
Said, possibly even just probe them for voltage.
Yeah, okay. Probe them for voltage just to see what's on them. That is a good point. Let's how should I do that? So that is vSense. I can do it through the breakout. So yeah, let's do that right now. All right, I am going to...
Ostrov said, bloody hell, it's like 4.5-6 apiece in DigiKey.
Yeah, I know, they're expensive, Henrik. That's why didn't order just like, oh, just order 100 of them. No, I ordered a few, probably like 5 or maybe 10. So, okay, just so that you can see it, I am going to trace this using the scope. So, what I'm looking at, which vSense pins are they? I'm going to come back to here. So what I'm going to do, just to explain, is I am going to probe on the vSense lines on the breakout. So these ADCs here, these should be the vSense lines that go down onto where the chip is. So if we come back to here and here, it is vSense 0 to 3, I believe, are the ones we care about. So let's, I'm going to leave you on this screen, so you're not going to be able to see me probing it, but at least this way you'll be able to see the scope trace. So I'm going to probe on ADC channel 0, and I'm probing here with channel 0, which is the yellow trace here. So there's 0 volts on channel 0, 0 volts on channel 1, 0 volts channel 2, 0 volts channel 3. Yeah, so we don't seem to have a short to 12 volts or any crazy thing like that going on with those. All right, back to the overhead. I will remove the scope entirely. Remove that, remove the ground reference. I should shut it down, shouldn't I? I probably should shut it down before I start sticking the soldering iron in its guts. Let's do that. I want that and that. All right. Now, this is going to be kind of tricky. Removing that chip. Is it shut down yet? Yep. Okay. I'm going to kill power. So, removing the busted ADC, I felt okay about doing... Oh, come on. I felt okay about doing that while the board was in here. Because it's kind of a brute force thing to do. I just put the whole soldering iron tip across all 4 pins and, you know, levered it up. It was a kind of nasty thing to do, but it's okay. But putting a chip back in, that is going to be an extra level of difficulty here. Come on, balance, balance. There we go. Okay, so I'm going to, I'll remove the jumpers off the, like those patch wires that are on the...
DS holder, the bodge wires as well, the red and black.
Yep. So I'm desoldering the bodge wires. And then I want to get off that ADC. And yes, I should put the gloves back on. Come on, come on. Now with the other one, because it was already obviously visibly blown, I wasn't worried about being brutal with it. But this one, I want to reattach, so I am being slightly cautious with it. I'm going to have to get it off and then probably clean up its pins. And this would be easy if the PCB was sitting flat on the bench and I didn't have this big connector in the way and I wasn't trying to balance everything in the air. Come on, bend it up. Bend it up. Here we go. Okay, ADC is off. And now I'm going to have to clean up its pins, clean up the pads on here. Yeah, I made a mess of it while pulling it off. I'll give you a microscope view in just a moment. Yeah, it doesn't look happy. Where are we? Microscope view. Microscope. See, it does not look clean and happy. Okie dokie. Let's just... where is the solder wick? Do a little bit of a... come on. Oh well, I'll do this side. Do a little bit of a clean up. And move it over here. A little bit of a clean up. There we go. Perfect. The perfect crime. Looks like it came from the factory. Oops. You know what just happened? Luckily I found it. It flicked out of my tweezers. Yeah, this is ready to sell now on the chip pull market. All right. As new. Only one owner, driven on Sundays to the local shops. All right, so now I need to get the chip back onto this. Okay. This is going to be Dodge City time. I've got the whole Test-O-Matic sitting in my lap. I'm going to try hanging the microscope off the edge of the bench. Got to find where the focus is.
Almost landed on the missing spares.
Yeah, could have landed on the missing spares. All right, so I'm going to just do a quick clean up on this to make sure we don't have any solder bridges. Oh, this is so awkward. I'm reaching around the edge connector and the side of the case. Okay, so I don't think we've got any bridges left there. And this is where we are going to put on the pulled chip. Oh, this is embarrassingly awkward. Where's pin 1? Down the bottom left. Okay. So I think it goes that way. I'm not going to be able to see this until I get it. Ah! I just dropped the chip again. How many times can I do this before I am no longer able to find it? Maybe this is the time I can no longer find it. Where did it go? Where did it go? I've got to stand up and look. Is it going to fall off my lap?
Miller said, before you mount it, do those tubes have exposed metal on the bottom?
No, they do not. There is no thermal pad under them. Ah, seriously? Seriously? I've dropped it again? It'll be amazing if it works after this. Is it attached to my jeans somewhere? Is it in my shirt? It's vanished. Oh, did I drop it into the Test-O-Matic? This is really a comedy of errors today, isn't it? All right, so if it flicked off, it didn't feel like it flicked. I just kind of dropped it because I was trying to get it over the Test-O-Matic case. Yeah, this is a great view. Hi.
Look on your chair.
Yeah, I did look on my chair. I couldn't see it there. I will look again in a minute. Yeah, it's not on the chair. The chair is quite clean, and if it was on the chair, I'd be able to see it. It's not there. I thought maybe it had stuck itself to my jeans. I can't see it on the floor. The floor is also quite clean, so I should be able to see it on this. I think this is a sign that I need to give up and do a couple of things. Consume some food and maybe get some sunshine into my brain through my head-mounted solar panels, and yeah.
Ostrov said, next time paint your chips green or red or SMT.
Yeah. Or maybe what I should do is paint my floor white so that everything shows up. No, it is probably still somewhere stuck to me. But I can't find it. It's not there. Doesn't seem to be. Nope.
Henrik Ostrov said, it's on the bench somewhere, look once more.
I will. I will. I'm just having one more look on the floor before I roll the chair forward, just in case I roll over it. Move the scope back out of the way. No, it's not on the bench. The bench is quite clear.
Said, in your shoe.
In my shoe? No, that's where I keep my money. All 53 cents of my life savings are in my left shoe.
Henrik Ostrov said, jeans pockets. What's that black spot on top of your head?
Jeans pockets. Black spot? Oh, that's just the pressure relief valve. Yeah, that pressure relief valve has been going off a lot lately. Where? I don't know. Yeah, jeans pocket is actually a possibility as well. It could have fallen in there. No. Nope. It has gone. It has disappeared into oblivion. All right. This is pissing me off now. I want to see what's going on with that ADC. Come on. Come on. Where? I'm sure I had some ADCs spare. I didn't use them all. I am absolutely sure that somewhere I have a little anti-static bag.
Scott Miller said, Steve took it, ran off.
Yeah. Steve took it, ran off, gave it to Steph as a present for Valentine's Day. Oh, hang on. I think I might know where it is. Let's see. Oh, yes! Yes! I found the bag. And they came from LCSC. That's why I couldn't find it in my DigiKey history. Look at this. It was... Yeah. It was in a box of stuff. Like I have... Look at this. Part of my process is that when I have things that haven't been put somewhere properly yet, so I have a whole lot of these boxes with anti-static bags in them. One of them is called file, and that means this is stuff that needs to be filed away somewhere.
Henrik Ostrov said, I just thought with LCSC order.
So if I have something that does not have a destination yet, I put it in the file box, and then this is the stuff that needs to be sorted. And that's where it was. That's why it wasn't in the sensors box. Right. Happiness. Okay, now we have 111.7s. How many? I ordered 10. Okay. Let's see what we can do. Let's put them. No, I'm just going to put U2 on. I'm not going to put U3 on because I want to see if U2 explodes. So, this train is back on the tracks. Now, I'm going to try this stupid trick with the microscope again.
Future reference. Always look in the file box first.
Yeah. All right. Back to doing stupid tricks with the microscope. Drag it all the way across here. Get a reasonable position. Get the focus right. Okay, about there. Now it's going to move because I'm balancing this on my legs. This is this is not ideal working conditions, which is why I keep dropping things. Okay.
Ken Ostrop said, now put on both MB if both stray on U2 smoked.
No, I'm not going to put both on. I want to put on just U2 and see if it smokes again. Yeah, so that's where we want it to be.
Subball at Fun said, Killer Geek said chip is near microscope on your desk. The lost chip is stuck under the board, shorting other things out.
Yeah, could be. Stuck under the board. Okay, let's just get one of the pins, or at least a couple of the pins in place so that it doesn't fall off. All right, is that going to stay there? Yes, okay. It's not soldered on properly yet, but at least it is hanging on the PCB. So now if I just clean the soldering iron tip. So now if I solder this other side, oh, this is so awkward. I can't even hold the soldering iron properly. I will get some solder wick onto this in a minute. Ooh, I just smelt melting. My soldering iron is brushing against other things.
Rick Ostrov said, look your oscilloscope wires.
Look at my oscilloscope wires. Why, to see if the chip is hanging there. I don't care about that chip anymore. I've got these new ones. Now, what did I do with my solder wick?
Rick Ostrov said, look your oscilloscope wires.
Was that a repeat again? Oh, come on. Urgh, this is nasty. I don't, I really can't tell if I'm doing this properly or not. I just can't get the soldering iron in at the angle that I need. But it's close enough that I am willing to power it up and give it a go. There's a whole lot of nasty looking flux lying around there. But let's try. And of course, I'm going to make sure that the scope is on. In fact, what I'll do is I'm going to power this up while the microscope, while the microscope is on and focused on it, because if this thing smokes, I want to see it. This would be classic to get this on film. Hang on, I'm going to zoom back out a little bit that way, do that, pull it over here, like that. Okay, I'm going to try to hold it still. I'm still balancing this on my legs. How can I get this angle a bit better? Can't quite see the whole thing. I want to get this right before I turn on the power. And focus there. There. Okay, here we go. Here's the countdown. Let's see if the smoke comes out. 3, 2, 1, go. Well, that was uneventful. That was... Should have I what?
Ostrov said, should have you cleaned the flux first?
No. Clean the flux? Clean the flux capacitor? No. Well, look, no smoke has come out at all. None. Okay. And is the Pi booting? I don't actually know what it's doing. Yes, the Pi is booting. if yeah, you can see it's booted there. So I'm going to come back to here. Ignore the scope, that's just doing stupid stuff. So let's log back into, so we had address 49 before, and now we want to see address 48. So let's get back onto there. Can't type the password.
Gerald42 said, "Is it getting warm?"
Is it getting warm? Don't know. I'll stick my finger on it and see. Well, the old Mark 1 thermal camera. Nope. Nope. Fingertip says it is not getting
Scott
warm.
Miller said, "John, you have a useful message in PMS about using SSH."
Ooh. Okay. Let's see. I'm just going to switch to this before I switch to Discord. Discord. Where are we? About using SSH. Oh, copy ID. Okay, yeah. Yeah. No worries. Yes, I know how to use key-based authentication. That's cool. I just haven't set it up, so I should. So what am I doing? That's right. I wanted to do this. Yes! Yes, we have address 48. Okay, now if I put U3 back on, let's see if we get the... this is now a 3-hour stream. Okay, does anybody want... Should I end it now, or should I put U3 back on and see if we get all of the devices appearing? Turn on VIN pass-through. Yes. Okay. Oh, Scott, watching you do password every time you restart it is painful. Yeah. Can you turn on... Yeah, turn on VIN pass-through, says Jordan Reese. Okay. And John Whip says, not a chance, we come so far. All right, what I'm going to do is turn on VIN pass-through, but I'm going to put the microscope back on it because I want to do this.
Put U3 back on.
Yeah, all right, I will put U3 back on and then I will definitely end the stream. All right, so I'm going to, how can I need to be able to see what I'm doing on the, okay. VIN on. So I am going to get the microscope over U2. There it is. Where's the focus? There. Okay. I am about to turn on VIN. Here we go. 3, 2, 1. Did you hear the relay click? VIN is now on. And nothing has happened. If I move across here, all the way, where is it? You'll see, there it is, the VIN power LED is on. So we are now passing VIN through to the device under test, and the ADC has not exploded. All right. And now,
design plexiglass legs you can screw into sides for servicing.
And now I'm going to run I2C detect, and we still have that device. So let's put U3 in, and we'll see if we get all of the devices appearing on the I2C bus. That would be a very nice result. Right, the Pi has completed its shutdown. Sorry, someone said something about plexiglass legs and I missed it. What was that comment? What was that comment? Where? No boom today, said Scott. Yeah, it's a pity. Time to... Oh, some Call It Fun said, time to design plexiglass legs so you can screw into sides for servicing. Screw into sides... Oh, I see what you mean. To keep the whole thing tilted up? Yeah, rather than trying to prop it up in a dodgy way. Yeah, no, this is just a... This is a very unusual situation. I should not be patching the PCB while it is inside the enclosure. This is me being super Dodge City. So I am going to, I'll jump back on the microscope again in a moment. I'm just dispensing an ADC out onto the bench. What have I got? Got my microscope, got my tweezers, got the soldering iron. Back to the scope. And
said, fun idea if there was a little tiny bit of short the heat from the smoke chip MB cleared it.
If there was a little bit of short smoke from the smoked chip and the MB cleared it, what's the MB? Oh, chip maybe clear. I don't understand. Yeah, okay. Back to here. I've zoomed out since I did the first one, so you've probably got a bit of a better view than before. The field of view that you have is much smaller than the field of view that I have through the eyepieces. So for setting the field of view for me makes it too small for you, and setting the field of view for you would make it too big for me. So it's a compromise. All right, let's get one pin in to hold it in place. 2 pins better, 1 pin good. What was that quote? Quote I just saw, heard a couple of days ago was, what was it? Enough is good, more is better, too much is perfect. Yes, we aim for too much. That is the goal. Too much is perfect. Yeah, normally I'd be able to just drag solder this and get it all neat, but not today, not today, not with the angles I can get on this. I have to resort to the solder wick. Back to the solder wick. It's the only way I can get in there. Come on. I'm holding the soldering iron with the tips of 2 fingers, because I can't even hold it properly with the clearance I've got around the enclosure. That is possibly okay. Not a soldering job to be proud of, but maybe it'll work. Yeah, okay. Alrighty. Now I'm going to leave this under the microscope and repeat the process, because it may well be that the smoke comes out now that both the chips are in place. So I'm plugging in the power lead, and I'll try to get both of the chips in view. So that's the 2 ADCs, and I'll hold it right there, and I'm going to turn on power. 3, 2, 1. No smoke so far. That's an anticlimax. You know, the conclusion I'm coming to is I must have had something like a tiny solder bridge, but I don't even know how that would have done it. There was something bad happened. Something bad that caused that first one to explode. So now it's booted, it's looking okay. Let's go to here, and now I am going to type my password in like a caveman. See? Just like that.
Said, look, my last comment.
I will. I2C detect. Yes, 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 yes. Look at that. We have 8 devices on the bus. David said, could the solder bridge have been so small that it evaporated after sacrificing the chip? Yeah, that is quite possible. Oh, Dodgy said, where do you buy this solder wick? Many places. This particular one may have come from DigiKey. It may have come from Core Electronics. I bought a couple of reels from Core Electronics recently. Oh, David said, I came here for the magic smoke. Not success. Success is so dull. Now, Henrik said, look, my last comment. If the chip burned up, the heat from it maybe desoldered the ever so slightly tiny short. Yes, that's right. So, Dodgy said, is John ever going to pick up the ADC from the desk and knock it off the desk onto my shoe? Right. Now you have to test all the adapter boards to see which one popped it. Jack's Tech said, where was the giant kaboom? There was supposed to be a giant kaboom. Yeah, where is the earth-shattering kaboom? Let's plug that adapter board back in and see what happens. Let's live dangerously. We will try for one last attempt at letting the smoke out. I'm going to grab this adapter board. I'm not going to fully reassemble it, just in case this does go boom. I don't want the deck and everything in here. So I'm going to grab this, slide it in. Nothing happened. Nothing dramatic. And you can see here that there is 5 volts and 3.3 volts coming through to this.
Turn VIN on as well.
And now I'm going to turn, yep, Henrik, I'm now going to turn VIN on. I'm going to touch the touch screen. As you can see, VIN came on. The green LED is on. Nothing bad has happened. Back to here. Run the bus scan again. And it is all still there. I think this was just an assembly fault. I'm going to blame myself, because it's usually me that's doing this sort of thing. Yeah, going for the viral moment. Killer Geek said, check the I2C bus. You know, I am far too hungry now to to go off on additional quests. Now I've got to reassemble the chassis. I need to... Okay. No, blame a faulty chip, says Scott. No. Jack's Tech said there was an exposed copper track under you too.
Nah, blame a faulty chip.
Yes, you're right. If you look at the scroll back in the... I'm not going to... Well, I can't now because there's a chip over the top of it. But in the video, if you go back to the bit where I was showing it under the microscope, down in the bottom left corner, I didn't comment on this at the time, there was a tiny little bit of exposed copper, which would have been to the ground plane. And which is this one pulled to? So the location of the little bit of exposed copper was right about here. It was approximately this area here. I don't think that was the problem though, because this pin was connected to ground anyway. There was just a little spot where the solder mask had come off. Yes. So Mitchell said, side QIR? Side question? So the way these guys did my coffee machine panel is the LED being lit allows the button to pull high, so LED off means button doesn't work. Interesting, simple but interesting. That is interesting. So they were using the LED as a pull-up. Right, so if the LED is off, the button doesn't work. Yeah, the things you find when you start investigating and pulling things apart. Yeah, I've got to reassemble. Okay, so what I need to do is add more ADCs. So this thing was a test. Okay, I also need to test the software. So far, we have not even talked to these devices. We can see them on the bus, but because we couldn't see them on the bus before, we couldn't talk to them. So the next step is actually...
Said, Thanks for the 3.5-hour stream. It was fun. I bet you would like one of the liqueur candies I've sent you. Once I promise you will get some more someday.
I can definitely do with some chocolate. I have some chocolate somewhere here. So yeah, next thing is, from a software point of view, is talking to these chips, the ADCs and the DAC. And then I need to revise this this PCB. So this PCB was not intended to be the final thing. This was just to validate the basic functions of the design, because we do not have enough ADCs and DACs on here yet. Now you can see up the top here, there are many pins, like signals. Where are we? Here, vSense 10. There's nothing going to it. I don't have enough ADCs and I don't have enough DACs. I just wanted to see if these ones would work. So I need to continue validating this design. I've got to get the code running to talk to these chips. And if that works, what I will then do is update this design to add more and populate the rest of these signals. So if we have a look at, so at the moment we've got 8 ADC inputs and we've got 4 DAC outputs. And if we look at the header here, we have, so these vSense lines, we have 16 vSense lines, which means we need 4 ADCs, I think. Yes. So we've got 2 of them that are populating these vSense lines. We need another 2 to populate these vSense lines. Then we need some more DACs. So we need 3 more DACs. We've got 1 DAC here populating these first 4, and we need to populate the other 12. So we're going to end up with 4 ADCs and 4 DACs. And currently we have 2 ADCs and 1 DAC. Yeah, so I'm basically just going to be...
Scott Miller said, have to wonder if a test-o-matic carrier for this board would have helped find the fault.
Don't know. Yeah, I don't know. Yeah, so I need to duplicate this. I need 4 of each of these. 4 ADCs, 4 DACs. And then I've got to plonk them on the board here and route them all. So that's going to be a bit of a pain in the butt. But it's got to be done. And yeah, then I can send this board off for fabrication for the updated version. It's also not going to be cheap, because these ADCs are like $5 each, and we need 4 of them. And then the DACs, I think, are a similar price. They may even be more. I can't remember, but I think they're like $5 to $7 each, and we need 4 of them. The bill of materials on this board is significant. We've got the MCPs, those are not cheap. We've got 3, count them, 1, 2, 3 INA 260 current sensors, and these are expensive. I can't remember how much, but they're like $6 or $8 each.
Tummy gurgle.
Oh yeah, my stomach is shouting at me saying, "End the stream." So yeah, this is an expensive board. The bill of materials alone
Henrik
on this
Ostrov
board
said 10 PCS adds a 33.3.
is just the bill of materials on this board is quite significant. It's not a cheap board, but the thing is, the whole point of this test-o-matic project is that you have one chassis with this board in it, and then you can swap out the modules, and the modules can be cheap. So you can test a whole lot of different types of boards without having to redo your work. You just need one chassis. Okay.
Have a great day, and remember, you have a nicely fried chip for lunch.
Ooh.
Extra smoky.
Have a look at the AD5593. It's an 8-channel ADC/DAC where you can select what each channel does. Oh, be still my beating heart. Let's have a look at this marvel datasheet, AD5593R. configurable ADC DAC with on-chip reference, I2C interface, 8 12-bit DAC, 8 12-bit, 8 GPIOs, integrated temperature sensor. What? What? What's its voltage range? It's got a 2.5 volt, 20 plus, yeah, 20 parts per million reference. Interesting. Interesting. Equivalent with SPI interface. Okay, there's an SPI version. Ooh, come on, where's its table? Okay, 2.7 to 5.5 volts.
Scott Miller said, "Wahahaha, new squirrel in the rabbit hole."
Oh yeah, I think I'm in love. So it's a combined ADC and DAC. So it's a 12
Have you
bit.
considered making the DAC ADC chips onto their own subboard, so if you blow them up you just slot in a new subboard?
Yeah, I think that has been discussed at some point in the past. That may well be worthwhile because of the dangers of damaging the tester. And these signals are exposed to the device under test and can potentially be damaged. So yeah, that is something that I would consider. If it turns out to be a problem and I keep blowing ADCs because devices fail, like the device under test kills it, then putting them on a breakout might be worthwhile. But it could also turn out to be totally unnecessary. Now, how many addresses? Where are the address pins on this thing? Where's the pin out? Pin out, pin out, pin out. It's only got one address pin. No. But still, that could still be okay. Now, DigiKey. Let's see how many bajillion dollars this costs.
I like the new IC as well. What's the price on it?
Yeah, that's what we're about to find out. What is the number? Tell me please. $16.50 for one of them. Let's not go BGA. Let's not go QFN if we can avoid it. So, yes. It is. Let's see what it is in more than single quantities. Okay, so it's 12 bucks. Sorry, you probably can't read this, can you? Here we go. It is 12 bucks in 10 up quantity. At 25, still $11 nearly. At 100, it's a bit over $9. So $900 to buy 100 of them.
Scott Miller said, but that one chip replaces multiple of the others.
Exactly. That's the trade-off. So in, say, 10 up quantity, let's say it's 12 bucks a chip. That replaces two chips that might be worth $5 or $6 each. So, yeah. Now, the thing is, the lack of addresses. This could be a problem. What I could do is use two of these to replace the four DACs. And where address input sets the LSB of the 7-bit slave address. Yeah, it's only got a single thing, which means you can only use two of these. I would need to use 4 of these in order to replace all of the existing ADCs and DACs. And I can't. I can only use 2 on the bus because of the address. And in fact, I wonder what the address is. I2C address. Let's see. Slave address. Oh, don't give it to me in binary. Give it to me in hex like any normal person would do. Where was that? Address bit 0, swapping, blah, where's address left shift 1. Oh, don't give me this. Don't give me this. Come on, what is the address? ADS, where is this going to have the address? Not found at. So this is a MicroPython library. No. Config decorator. Where's the address? Address. Is someone telling me the address? You can do a trick with GPIO controlling A0 and so select only the one with A0 equals 1. Killer Geek. It allows change of A0 line before talking to them. Yeah, that is an interesting trick. I think, hang on, was there an SPI version of this? I have a feeling there might have been. So that would be an alternative as well. Possibly do an SPI thing. Now, where is the address? ADCP address. Right to self.address. Where is address set? Where is it setting address? Self.address equals address. Okay, address equals what? Hex 11? Really? That seems like a strange address for an I2C device. Could be. Could be. We don't have anything else on there, do we? No, we've got stuff on 2021. We don't have anything on hex 11. So maybe? Maybe? I don't know. Okay, my brain has totally left the building. It's now 3.5 hours into this live stream, and I am zonked. So, Henrik suggested, can you use TCA9548, a chip with them, which is the, which I think is like an I2C bus multiplexer, possibly. And Killer Geek said AD5592R is the SPI version. Okay. Jay suggested making another I2C bus. Wagonloads asked, are there any ADCs that have an I3C data bus? I don't know. Wagonload says, I'm designing a circuit where the ADCs are on opto-isolators and isolated DC to DC converted so I can measure the output of 2 different power supplies on isolated grounds. Clever. Okay. Seriously, I am losing the plot now. I don't know how people do mega length live streams. Yeah, Wagonload says there are I2C address multiplexers so you can use 2 or more devices on the same address. Yes, I've used those before. And also you can get address shifters as well. You can get a device where you put it in series and it basically accepts one address on one side and it spits out a different address on the other. So it fakes the address so that you can arbitrarily set devices to whatever I2C address you like and they don't know the difference. They think you're talking to them on their original address. So I've done that as well before. So there are solutions, but I am way beyond chasing those solutions right now. I can't believe I have just talked for 3.5 hours. I have used my entire word quota for the week. So if anyone tries to talk to me this week, I think I am going to pull out post-it notes, maybe write you a little message and hand it to you, because I am going to be unable to speak. So I'm going to go. I hope you all have a fantastic week, and yeah, I will talk to you when I regain the power of speech. Thanks everybody for your suggestions. It's been really educational and I've learned a lot today. So have an awesome week and I will talk to you later. See ya.